Dudes. Yeah. Cool. Perfect.
Okay. Okej, hej och välkomna allihopa till Internetdagarna och våran webbperformance track. Hello and welcome. So, I'm Peter. I work for the Wikimedia Foundation and trying to get Wikipedia faster. I built a tool called sitespeed.io together with Tobias, and we are soon going to release the 4.0. And you can reach me on Twitter on Solislav. I'm the host, but we have another host, and that's sitecolon.se. That's a tool that the Swedish Internet Foundation has built, where you can actually check your site and get some tips on how you can make your site better in performance-wise. So you can try it out after the sessions today. And you can also give feedback, so we know how it can be built, and if we can do things better, or if you like it. And it looks like this. Okay, so I'm going to start a small introduction before Tobias is going to talk. I'm going to talk about who invented web performance. So we in Sweden knows, but you other guys, you the speakers, will know after this talk. So a lot of people think it's Steve Souders at Yahoo or Google, you know? Like that's the common thing that people think, okay, web performance, it was invented by Steve Souders. But we have a lot of good things coming from Sweden, right? We got Spotify, we got Lagom, we got a lot of different things, right? So could it be that maybe we Swedes invented web performance? I don't know, let's see. But if it's like that, you know, there's one guy that's going to be a little bit sad. So let's see. Okay. Anyone know who invented web performance? Okay, the Vikings. Yeah, so the Vikings invented web performance. You don't know, because it's like this. They have the thing called runstenar, or runic stones, and that's like the computers of old times. And there's one stone called rökstenen, or the smoke stone, and you see it here, that has some very cryptic things on it. So we called in our best scientists in Sweden. I don't know if you know him, but he's the Swedish king, and he tried to figure it out what it was. And so, just so you know, the runic stones are not written in Swedish. It's an old version of Swedish, so it's hard to understand. But the Swedish king understands it after some time, and the answer from the runic stone, or the rökstenen, is Steve Souders' rules for fast-loading websites. So when he was going through the runic stones, he actually said he can see that on the stone there was the rules for the Y-slow, or how you can make really fast sites. So we know that the Vikings made web performance, and now we're bringing it back to Sweden again. And so we have a lot of great speakers here today. And Tobias, that works for Akamai, and he knows maybe most about images and image compression in the world, and he are going to show us that today. So thank you, Tobias.
No pressure. Thanks, Peter. Hi, everyone. Okay, let me quickly switch that around. So I'm just going to dive right in. If you have any questions during my talk, high performance images, feel free to hit me up on Twitter. I'm going to reply, and we can have debates months after this talk if you try any of the tools I'm going to talk about today. So how do I get started? I think I'm going to tell you about how I got started into that whole business. Oh, and the clicker isn't working. Damn, why not? Clicker. Ah, here we go. So before Akamai, I had a different life. And the different life was doing websites. And while I was creating websites, I got into web performance bit by bit. And in 2012, I had a customer that wanted to launch a site, and it was the first customer who actively, without me evangelizing for it, came to me and said, "We want a performance budget for that site." And I was like, "Oh my God, that's amazing. Yes, finally, after years of talking about it, a customer who actively wants that. That's so cool." I was so happy to have them. So when I got their large zip files with all the data that you need to create the website, what was in there, of course? PSD files with 90 megabytes of size. Obviously, right? So I thought I can't possibly use these images in that kind of detail and resolution that they're shipping them, that they're sending them to me. For the web performance, I have to optimize these images, compress them so that they load faster. That was my basic idea. So I compressed them, and they weren't small enough, so I compressed them some more. They got some visual artifacts, but I was happy with the file size, and I thought, I'm not going to tell the customer, because that customer was obviously going to make trouble if I told them, look, there's artifacts in the images now, so I'm just not going to tell them and see if they're convinced by the web performance rather than the visual experience. That didn't work. So I showed them the initial version, and they were like, the first thing they did was like, there's compression artifacts in that image. And I was like, yeah, there's compression artifacts in an image. Damn, going back to the drawing board here. So how do I get rid of the compression artifacts? And that was the proverbial Alice going down the rabbit hole. 3 years later, I'm standing on that stage and talking about it. So the problem I was facing back in that time is actually the problem of hero images. Hero images are so common nowadays in web design that they have had their own name phrased. And actually, Steve Souders, Peter already mentioned, has also coined a term for them now, the hero image delay. Because hero images are the biggest problem when we load images because they're so huge and because they're the first visual thing that people see and they want to feel positive about engaging with the site. And if a hero image has compression artifacts, then people think, well, that's a bad website. That's bad for the brand awareness. So we don't want compression artifacts on hero images. That's a problem we have to solve, and loading images faster. So the problem can be expressed in data. These are graphs from the HTTP archive by Steve. And this shows how much image data there is in websites right now. This is from October, the beginning of October run, because the end of October one was broken for me for some reason. But the beginning of October run shows the trend that has been there for like 2 years now. Images make up 2/3 of all the binary data, all the data that we ship for websites. So a huge chunk. In terms of HTTP requests, it boils down to 20 to 60 HTTP requests on average for images alone. That's huge. And images have a very, very high correlation to page load time. That means when the page has actually finished downloading completely, so that all the little spinners stop. Of course, that doesn't mean that the website is unusable until that point, right? There's a big difference between speed index and perceived speed index, the usability of a site, and the page load event. They are completely separate. So don't think that images are the one thing that are making every website slow, because there are websites that render very fast without having downloaded all the images. But for the page load event, they have the highest correlation. So it's kind of important to fix that, because they are that big of a binary chunk. If I want to find out which type of image I should fix first, I should probably tackle the biggest chunk first, right? So I have the huge win at the beginning. I mean, I don't want to start with SVG optimization. That's minute. I want to start with optimizing JPEGs. So today we're going to look at JPEGs primarily. If in the Q&A, by the way, you have questions about any other image format, really any other, I doubt that there's any other image format that I don't know by now. Hit it, but I'm going to talk about JPEGs during this talk. So for JPEGs alone, we have like 20 to 40 HTTP requests. It's still massive. That's weird. I'm not going to dance to that. And for JPEG transfer size alone, that's like 400K for the average Alexa top 2,000 websites. That's massive. And the problem is users hate to wait. So we really have to fix this JPEGs issue. We really, really have to do that. Also, because now we're facing, I mean, this photo is famous, we're facing the problem with that mobile is out there and mobile is the de facto standard. Working for Akamai, I can tell you that we are now seeing more mobile than traditional traffic sources, and mobile is the de facto new standard. We can't say landline and then there's mobile. No, the web is now mobile, and the rest is just dying away slowly while carrying our internet with us. So these big binary chunks are a big problem because they have to go over that wireless connection. Also, with responsive images, we now have to ship different versions of an image, and we need to optimize all of them for instant delivery. So, curious monkeys that we are, what can we do for JPEGs? The thing is, we have to work with JPEGs because JPEGs do something very, very nice. They do full color. That's what any other image format that was out there in the past didn't really do, and they transport images almost like we see them with the human eye. So that's really, really good. And they trigger emotions in us. So when we see such a full color photo on a JPEG, that triggers so many different areas in our brains that we engage with websites on a completely different level as if we only were viewing a text-based site. So be it buy that product or donate this amount of money, images get us to do these things. Text-based alone doesn't cut it anymore. People need to be emotionally engaged to the content that they see in order for action to be taken. So emotions are super, super important to get your visitors to do the stuff that you want on websites. Engagement. The images are super, super important for engagement. So first of all, we could look at workarounds. How can we ship images with proper resolution and stuff without causing huge delays for our customers? How can we do that? So first of all, you could async everything. That's a pretty good approach. By the way, lots of websites that load very fast at the top of the screen, they do asynchronous loading because they're still shipping 60 JPEGs, but they're not loading them all at the beginning. So one thing you could think about is, do I really need to ship 60 JPEGs over a mobile connection to my customer to make them convert? And the answer is in 19.9%, no, you don't. You need to ship your first or second image, and the rest can be that is below the fold can be loaded asynchronously because that helps. Also, your clients will like you because you're not wasting their data bandwidth. I'm on roaming right now with my cell phone. I have 150 whooping megabytes available for all the time I'm staying here. That's not a lot considering that the website now weighs in at almost 3 megabytes. So I really can't do a lot of browsing. So if you managed to only show me 2 images to get the information across instead of 60, well done. I'm going to love that website. So yeah, async loading. Check it out. Also, a thing that I really, really like that Guy Pojami, former CTO of Akamai, invented is called low-quality image placeholders, another thing that works fantastic on mobile. And that is, you want to give people the impression that something has already loaded, but you still have the problem that you might need to ship dozens of kilobytes for that image to show. So what Guy Pojami invented is a low-quality image placeholder that already shows a colorful and also shapeful preview of the image that is only a couple of hundred bytes big. And then when the high resolution image is loaded, the image gets swapped out. There are JavaScript libraries that can do that right now. They're free and available on GitHub, so that's really easy. There's a picture fill, for example, by Scott Yell, I think has a lazy loader. Alexander Farkas's Lazy Sizes does that too, I think, if I remember correctly. So they're really, really cool. Gaipo wrote a blog post about it when he introduced it in 2013. Facebook has picked this up now, and they wrote a really nice blog post about it, how to do it in 200 bytes. So that's really cool. It's very nice. Oh yeah, by the way, everybody taking photos, the slide deck is already on Speaker Deck. So if you want to get all the links, just go to where.tobias.is. That's my website, and there's a link to the Speaker Deck, and you can find exactly the slide deck right now and get all the links. So yeah. LCAP, low quality image placeholders, another nice technique to work around the fact that we have to ship big binary blobs of images. Show a small placeholder until the big image has loaded, swap them out. Gives the user a nice visual impression, and they can already start reading the content, maybe even get a feeling for the colors of the website or the image. Works. You don't have to show the low quality image placeholder for seconds. You can show it for a couple of 100 milliseconds and then swap it out. Still gives the users a better impression than waiting for an image to download. But these are all workarounds. So what I actually want to talk about today are the proper tools to do it right. So workarounds are neat, but we need to fix the actual problem. So let's talk about tools. What tools are available for JPEG? Well, the JPEG encoder. The JPEG encoder is as old as it gets. The JPEG standard is from 1992, and when I first got into image optimization 3 years ago, I was like, that can't possibly be good anymore, right? Because it's not new. If it's not, that's the Western capitalists thinking. If it's not new, it can't be good. So yeah, I thought stuff from 1992 can't possibly be good. But so I dug some more. But actually, it turns out JPEG is pretty cool. JPEG in 1992 has been engineered very, very well. So what you see in the background here are Internet Explorer 2 and is it Netscape Navigator? Yeah, the first browsers to support JPEG in 1995. The reason why that came to be is when Mark Andreessen launched, what was it, Mosaic, it only supported GIF images with 256 colors, but people wanted to view full color images, so we needed some new standard to ship full color over the web. And the JPEG standard had been fully standardized, and super important, it was open source. So you could just use it. It wasn't a proprietary image format. You could implement it. And so people did to solve that problem that people want to view full color images. So, bless you. JPEGs are the, so with libjpeg, which is the standard JPEG library, we can optimize images already. Shall I show you that? I'm going to show you that in a second. So libjpeg is under the hood for most image optimization tools right now. If you use the GIMP or actually Photoshop is a bad idea. GIMP, this is something that uses libjpeg under the hood to optimize JPEGs. I was about to say Photoshop, but that's not true anymore. Photoshop has switched in CS2 or something to a proprietary library they're using. They're not using libjpeg anymore. They basically reverse engineered the whole thing. But libjpeg is under the hood of most of the common things that render JPEG because it's the open source library maintained for that. And it can do the image optimization with quality loss and everything. It's kind of neat. But as I said, I had the feeling it was old, so it must be bad at the beginning. And the funny thing is, so did other companies. So in 2010, other companies thought, JPEG is from 1992 and we have that image problem. We need to solve that by obviously creating something new because new is better. Enter WebP. That's Google's attempt to solve the image optimization problem. WebP was created to fix it all in one go. Right now we have like JPEG and PNG8 and PNG24 and GIF, out on the web. That's the most predominant formats. And now SVG, of course. And WebP tried to solve that all. It tried to do full color, 8-bit color. It tried to do animations and everything under one hood. And when WebP was launched, they claimed, well, it's like almost 30% smaller in all the compression tests we ran. So everybody was super excited. And Google has a good marketing team, so everybody heard about WebP and got excited. The problem with WebP is the following. Oh, yeah, I'm not sure if that's going to work, though. Let's see. Because I don't have do I have internet connection? Let's see. Yeah, yes. So yeah, the can I use data as buffered? Sorry about that. I don't have uplinked right now, but this is still true. So the problem with WebP is this. Nobody implemented WebP but Google. So WebP was available on Chrome, and that's about it. So that's a huge problem, because if browsers don't support an image format, people won't see the image. Actually, Facebook, they switched to WebP for a while. They thought, well, the big wins from WebP are going to make our customers happy. So they switched to WebP, then found out customers hate downloading images and finding out that they can't open them with other tools than Chrome. And so they switched back from WebP. Also, people hated something about WebP that we might see today. Let's see. And that is the uncanny valley effect. Who knows what the uncanny valley effect is? Okay, I'm going to explain it then. It's that when you view a human face, let's say that's computer generated, it sometimes looks like it's almost natural, but something's off. Look at modern 3D games right now. You look at these faces, they move, they talk, they have their lip movements, and you're like, that's kind of neat, but it's also something is off with that face. And that gut feeling that every human has as an identifier if the human face in front of them is real or not real, that is the uncanny valley effect when you feel that it's not real. And WebP, when it compresses skin color, gives skin sometimes some sort of plasticky look, as if somebody was wearing lots and lots of makeup to make the skin shine. So people had the feeling that when they viewed family photos in WebP on Facebook, that people were having this uncanny valley effect. Faces were shiny and looked unreal. So people were like, this compression looks really wrong, Facebook, what are you doing? And then Facebook's like, yeah, we switched to WebP under the hood. And then they switched back to JPEG because people didn't like it. So before I keep talking like this, let's look at this for a while. Oh, sorry, wrong tool. Go away. Okay. So, how do I do this? While the keynotes were running, I went up and took a photo because I wanted to show you all I'm talking about today live. This is the large A1 conference room from like 45 minutes ago. This is the original photo I downloaded from the iPhone. Of course, the iPhone already takes a JPEG photo, which means it's compressed. So if I wanted to find out the quality of that JPEG, it's 96 because that's the default setting for the iPhone right now. Since it's unlikely that I want to upload 1.8 megabytes of image data to the web raw, I already created something that I'm going to call source JPEG. That is a recompressed version of that same image. This one is 7068 pixels wide and is created by the GIMP in quality 85 with the Save for Web option. This is the base image for our tests now. The reason being, I wanted to create something that's runnable while I talk, and I wanted to create something that's real. So if I'm going to upload an image to the internet, it's very likely that somebody uses some sort of editing software before uploading the image. So I kind of mimic that process. So our source image here is 83 kilobytes big and 768 pixels wide. Now with the lib JPEG in GIMP, we get 83 kilobytes, right? So let's see how well WebP does. WebP is supposed to be doing really, really well. If you install WebP, you get C WebP on the command line to run it. We said the quality was 85, so I'm gonna go with the quality of 85 for WebP. The thing here that you have to remember is that quality metric is completely void. So it doesn't transport. So you can't go quality 85 in WebP equals quality 85 in JPEG. That's not the same thing. Even in between different JPEG encoders, that quality setting is not defined, not standardized in the JPEG standard. So you can't transport that number. But for argument's sake, I'm using 85 for WebP here too. And let's see how small it gets that image. So it's going to be really, really fast. Yes. Yes. Because of the arguments I just said, because I want to show the gains between a normally created file and WebP and other stuff to come. So let's see how well we're doing. So, ignore the Peter. We have the WebP format here now, and that's on 65 kilobytes from 83 kilobytes. That's pretty good. And the problem I've been describing is this: if I want to open WebP now, the only tools that I can open it with is Affinity Photo because I just bought it and it has a WebP plugin built in, and Google Chrome. So that's the problem. I can't use Preview, I can't use any of the usual tools I would use for image manipulation because WebP is a format that is not supported outside of Chrome. It's a problem for normal users using images in a normal way, not editors. So that's why WebP isn't so popular. But as we have seen, WebP has a huge file size gain. So that's why people still try to implement WebP. And what I'm going to try to show you today is that it's possible to do that with JPEG too, because JPEG is supported in all the browsers. The thing is, when Google started with a business with WebP, other companies jumped in too. Google and Microsoft were battling for standardization of several stuff for a couple of years, since 2010 to 2013. The most remarkable being HTTP2. So Google launched Speedy, and Speedy went to be HTTP2. Microsoft standard is not even remembered. I don't even remember the acronym anymore. But the same thing happened for WebP and JPEG. Microsoft thought Google is going to launch a new image format. We have to do something about that. We have to create our own standard because, you know, we want that predominance there. So they just had bought a company that was creating a JPEG fork that was able to handle HDR images, and they released that as JPEG XR to be a different proposal for a new image standard. The thing with JPEG XR is they botched the open source licensing at the beginning, so people didn't even implement it. So JPEG XR was dead in the water for a while everybody talked about how great WebP might be in 2010 to 2012. And then when JPEG XR finally was available under GPL, nobody cared anymore. So that's the problem with JPEG XR. It's out there. It's supported by exactly one browser or one rendering engine. But yeah, it's not really doing that well. Let's see here. Yes. So that's the support for JPEG XR. Let me put that on the top of the screen for you. So that's IE from 9 onwards and the new Edge browser. That's it. So everything Microsoft had control over supports JPEG XR, nothing else. And there's also, again, like with WebP, no intent to implement by any other browser and render creator. So neither WebP nor JPEG XR will make it into any other rendering engine than the ones controlled by the people who proposed the format. That's a problem. So that whole debate about WebP and JPEG XR and stuff always reminds me of that XKCD comic that we need to fix the problem with too many standards being out there because, we need to find the one solution that fits it all. And a couple of months later, bam, we have +1 standard, but the problem isn't really solved. I really had to laugh hard when I read Leah Verou's CSS Secrets, by the way, because she had a very good quote in there from the W3C. That are kind of true. That reminds me of that whole debate because these standards for images, they weren't formed to benefit the user. They were created to benefit that one specific company who had a lot of weight. That's the problem. The end user wasn't in the focus. And that's kind of what this quote really expresses very well. The end user gets botched because, other interests. Enter Mozilla. But Mozilla, being known to be nice, they did something really awesome in 2012-13. They said, pardon my French, fuck all these standards. We're gonna show that the actual JPEG that we have been working with since 1995 actually can do what we want, what we need it to do right now in modern web design. And they created a study to show that a new encoder for JPEG that is smarter than the older encoders we had available was able to compress JPEG just as efficiently. The first study was launched in November 2013, and then again in 2014, in the December 2014, I think. And then they open sourced the tool that they created to do this study, and it was called ModsJPEG. Love ModsJPEG. By the way, the image in the background is in the San Francisco office. I love this. I have to get a copy of that. That's Red Godzilla finding Google Chrome UFOs. I find this so cool. I need to have this in my living room somewhere. Awesome picture. So ModsJPEG was open sourced, and they showed that it was really, really awesome, and that it could do very nice things. That it was smarter and better than libJPEG ever was. So, and because it's open source, we can show what it does right now. So let's see. If you install ModsJPEG, by the way, because it's supposed to be better than libJPEG, you get again, like with libJPEG, you get CJPEG for compressed JPEG on the command line. Don't get confused by me using ModsJPEG on the command line. This is just a symlink. I always have to mention it. So I just symlinked CJPEG from ModsJPEG to be available on the ModsJPEG command. Again, I'm using quality of 85. Oh yeah, by the way, the source image was progressive and baseline optimized. No, and no EXIF data. I always forget to mention that. So no EXIF data and progressive rendering for the JPEG. And we're going to use the same parameters for ModsJPEG for comparability. That was really, really fast. ModsJPEG is cool. Oh, typo. So we had a source image of 83 kilobytes. And now, because I've been talking about ModsJPEG and how awesome it is, we have a great file size saving of 3 kilobytes. That sucks. What I've been talking about for the last 5 minutes, right? I mean, if I say ModsJPEG is that great, why the hell is that not working? Anybody know? No? Anybody listened to this talk before? So the reason being that ModsJPEG is super conservative in its default settings. It, like my customer, clearly wants not to create compression artifacts. That's its main intention. It wants to compress images as optimally as possible, but it doesn't want to compress, create artifacts on the process. So if you use ModsJPEG without any fine-tuning, it is super, super conservative. That doesn't mean, however, that it doesn't create superior results if you fine-tune it. And for fine-tuning, I propose the following. We need to find out how much difference there is between an input image and the output image to make sure that we give the best parameters for compression to an image. And to do that, we have to find an algorithm that identifies these differences between an input and an output image. The thing is, the human visual system is kind of tricky about, we see more red than we see blue, we see contrasts better than differences in color, all that kind of stuff. So it's kind of difficult to model that into an algorithm, but people have tried for 30 years. So we had peak signal to noise ratio to identify this in the past, and it found out, well, peak signal to noise ratio is not that good. So in the last couple of years, I think like for the last 10 years, people have started working on something that's called the similarity index. And the similarity index has gotten, like in open source, a lot of forks to get closer to the human visual system. There is CY SSM by now for complex wavelength analysis and stuff. So there's lots of good forks that try to get as closely as possible to create an algorithm that can identify differences like the human eye would. And the tool I've been using is called DSIM by Cornel Lisinski, who's using ImageOptim on the Mac to compress images. Yeah, cool. Cornel Lisinski, the creator of that tool, also created DSIM. So DSIM is very, very nice in the sense that it measures the dissimilarity, which I think is a kind of more intuitive than measuring from the minus realm in the numbers. So the structural similarity index would give you something between -1 and 1, which I think is weird. The dissimilarity index X-ray expresses that in a positive number, which I think is more intuitive to the human eye. So if I wanted to measure differences in images to make sure that the image is still acceptable, I could do this like this. So I've got DSIM compare. Again, it's a symlink. Don't expect DSIM compare if you install DSIM. And we want to, let's say, compare the source JPEG to the mods JPEG version. And you get this integer. And you can read it like percentages. So if this was a 1, this would mean 100% of difference. Then this is 2-digit percentages, 1-digit percentages after the comma, after the comma, after the comma. So this means mods JPEG has created a visual difference of 0.038%, basically nothing. So mods JPEG was super conservative in this run. And we can use this number, the dissimilarity index, to fine-tune mods JPEG to be more aggressive about compression. The reason being, human eyes, again, faulty, are not as good as detecting differences. So there must be a sweet spot, how much difference the human visual system can accept before it detects these differences. And the truth is, there has been little study about this, but there is one company who has run studies on this, and that is, Tammy Everts with, what's her name? What's the company's name again? Redware. No, the company they bought that doesn't exist anymore. Something with S. Strangeloop, thank you. Strangeloop doesn't exist anymore. That's why I didn't remember the name. So Strangeloop ran these tests, and they found out that the difference that a human can accept for input and output image is about 1.5%. Good number, 1.5%. So we can fine-tune for that. We can create a tool that gives us the optimal image that has exactly 1.5% of difference, because that is what the human eye won't see, very, very likely. So, of course, I built this because, yeah, I was on the search for the perfect image optimization tool. So the tool is called CJPEG DSIM, because compressed JPEG DSIM with a dissimilarity index. It's basically a proof of concept, but it runs well enough, and it's on GitHub. And it looks like this: CJPEG DSIM, and I'm telling it to use mods JPEG under the hood for the JPEG encoding, and I'm giving it the source JPEG as an input. And now you're going to notice it's going to run a while, a couple of seconds. The reason being, it doesn't just create one image, it creates about 5 or 6 images, because it does a binary search. It starts with a JPEG quality of 80, calculates the dissimilarity index. If it finds out the dissimilarity index is too low, it increases compression to reduce file size, and vice versa if the dissimilarity index is too high. So it's going to take a while to process, but at the end, we're going to get an image that is really, really small. That's this one. And look at that, 43 kilobytes. That's pretty, pretty cool. I'm very, very proud of that tool. So we're gone from 83 kilobytes to, oh, 81 actually on the command line. That's weird, rounding. 81 kilobytes to the conservative 80 with mods JPEG without enhancements, and then down to 43. And now you might want to ask me, well, are you sure that we don't have compression artifacts by now? You know what, let's take a look. So we've got the source, looks like that. Oh, let's put them side by side. Maybe that's going to work a little better. And we're going to look at this version too. Okay, actual size. No, go away. So, I mean, I know it's a projector and stuff, but anybody see any major errors in this image? On the right-hand side, that's the one that's optimized. Any huge compression artifacts visible that's going to make you, oh my God, you can't watch that image. No, nobody's screaming? No? Good, because we are at 1.5% of difference. So let's run that again. So, source gpip. And there we have it. 1.42% difference, visual difference with a measured with a dissimilarity index. That's a pretty cool saving, especially considering that WebP is actually bigger. I mean, of course, WebP also has a bigger quality setting, so if we were more aggressive about the WebP compression, we would still get a smaller WebP. But at the end, with CJPEG DSIM, you get WebP file sizes while you get JPEG level support. And that's awesome. And this is all thanks to mods JPEG, because mods JPEG is that good under the hood. So my tool is just a wrapper around mods JPEG. The main weight is of the task is basically carried by mods JPEG. So that's really nice. The thing is, on large images, you might see differences. So one of the reasons why nobody shouted is because there was lots of detail in that image, and it was, it has this depth effect and stuff like that. So there wasn't a huge contrast corner where you might go, oh my God, this is a compression artifact right there. But if we had an image with a large contrast corner, we might see these compression artifacts with CJPEG DSIM. So even after I created that, my task wasn't done. I was like, I'm still not happy with this. So I thought about how does JPEG work when it compresses images? And how JPEG works is it iterates over the image by 8x8 blocks. So it goes from top left to bottom right in 8x8 blocks and optimizes these blocks, processes these blocks. That's the way the engineers built it that way at that time, back then. So I thought, well, maybe I can leverage that process. Why not, instead of having a global quality setting, iterate on the image and find out different quality settings for different parts of the image. And now we're back to the topic of quality. So again, we started off with a quality of 96 for the source image, for the input image, right? Then I used GIMP to create the source image we're working on, and I set that on 85. Then I said, let's automate the quality setting for mods JPEG so we find an ideal sweet spot with 1.5% of difference. That's the CJPEG version. And it's on 59, which might be surprising to lots of you, because if you were using JPEG compression in the past, you might think 59 is far too low and would definitely create artifacts, but not with mods JPEG, not if mods JPEG does its job well. So these are the quality settings we've been using so far, but they're all global. This is one quality aspect for the entire image. What if we could adapt the quality per tile? Because why not? Why the hell not? Who says this isn't possible? So I dug a little deeper and created another tool that can do that. And that tool takes a lot of time, so I'm going to start it right now. It's called Adapt. It's also available on GitHub, and this is definitely just a proof of concept. Don't use this in production. There are people interested in porting it to C. That's very nice. I'm currently thinking about porting it to Golang for funsies, basically to up my Golang skills. If that's done someday, this might run better. Right now, don't use it in production, please. But I can show you, because of its proof of concept, that it works. How does it do the things that it does? Because we need to find out which quality setting to use, right? So I thought, where do I get compression artifacts when I optimize an image? And I already gave it away. I get compression artifacts at high contrast corners. So let's look at the source image again, and maybe we can detect areas where we might see compression artifacts. So there is, for example, high contrast corners here, from a bright setting to a dark setting. Or this one, yeah, this one will definitely create a compression artifact. This is because we have a very strong switch from dark to bright. This is where the JPEG encoder would botch up. It would make a mess and create a compression artifact. And that's bad because the human eye detects these. So I needed to find out where high contrast corners were inside an image and exclude them from compression. I first started off with an all-directional Sobel edge detection algorithm to do that. It basically just creates white lines around the corners and with that map, you can detect these corners, measure if there is a line inside a tile of a JPEG, and then exclude this. But after a while, I wasn't satisfied with that anymore because I figured, let's say I want to optimize a photo with a face in it. Like here, like lots of people with faces. I would get a corner here, I would get a corner here, I would get a corner here, I guess. You know, Sobel would detect these corners, but Sobel wouldn't detect corners inside faces. So I would get compression artifacts inside the face, which is bad because uncanny valley effect again. I don't want that. I want faces to look pristine. I want the main meaning of each image to be pristine under compression. And this is where Jet came in. That guy. So we thought about how can we do this? And we came up with the idea of using a saliency mapper. A saliency mapper is an algorithm that detects important parts inside an image. Hilary Mason already mentioned that in the keynote this morning, that image analysis is a super important topic this year, and it's absolutely true. Because we need to be able to deal with all that data and to make our tools smarter, we need to be able to tell computers what's inside an image. And that's what saliency mappers have been created to do. So they started off as university projects in, I think, 2005 even. And then there were a lot of white papers on how to do this, and they got smarter and smarter. There was also, from government side, there was the need to process video data in real time to identify objects inside CCTV. So that's why they got more funding and they got better. And by 2012, they got good enough, I think. That's at least my opinion. And I read lots of white papers, and I tested lots of those. Of those tools, and then I thought I had one that is actually worth my while. It was created by a university in Switzerland, and it was under open source. And I contacted the people and got them to agree to a proper open source license for that thing. And it's called the Maximum Symmetric Surround Saliency Algorithm. I know, a complicated term. That's this one, MSSS, also on GitHub, by the way. And MSSS highlights differences inside an image. And that's not good. Oh yeah, because I'm not on the desktop. Here we go. So I just ran the saliency mapper, and the saliency mapper outputted this. This is a black and white map of the input image. White areas mean area of interest, black areas mean area, nobody cares. It does this by a algorithm of luminance, chrominance, contrast, etc., to highlight interesting areas. So it found out that these faces here are interesting. It found out that this bright light back there might be interesting. See, the cones that I mentioned at the beginning are also highlighted. And now, because JPEG iterates by 8x8 blocks, I can go from top left to bottom right in 8x8 blocks and find out how many white pixels are in each 8x8 block. And this is what Adept right now running is currently doing. So it finds out all black, uninteresting, all black, uninteresting, all black, uninteresting. And then after it iterated a couple of rows, it'll hit here. And it'll find out, oh, this is actually a lot of white pixels inside this blocks. I think the threshold I put in is something like 55% of white pixels for each of the tiles. And if it hits that threshold, it says, wow, that must be an interesting tile. Let's be careful about compressing this. So all the tiles that are deemed uninteresting are being exposed to a high compression ratio. I think 69 right now in the adapt tool, and all the interesting tiles are compressed with the quality setting that the JPEG had when it was entered into adapt. So it automatically finds that out and uses the source images JPEG quality for the interesting tiles. And that way we are able to get rid of compression artifacts. And the depth has finished. That's great, because I was running out of words. Let's do that on a terminal because it's prettier. So adapt has finished. Let's see how well it did. Again, we have the 81 source, and we're going to compare it to adapt compress. That's this one, 65 kilobytes. 65 kilobytes, that's still very, very good savings. But here's the kicker. We have created an image that is very, very, very undistinguishable from the source image. Again, let's prove it by math. So, let's actually use that because it was good. So, we have this for the CJPEG version, which was highly aggressive in compressing and might have created artifacts. And we have this for the adapt version. So from 1.4% difference to 0.7% of difference. Huge drop. So we actually increased the quality between input and output image again by half, if you want so. So there's half the difference between these two. That's pretty good. And we still have significant file size savings. So when to use which is a question I get asked a lot. And I strongly suggest adapt is very good for hero images, because this is the first thing that a user sees, and especially if they have important details in them, you don't want compression artifacts. So this single hero image might very well be worth your time to run through adapt, although adapt takes ages to run. But all the other images might actually be worth CJPEG DSIM. So I've talked a lot about how to adapt JPEG quality for the contents of an image now, which parts of an image are interesting and how to adapt the JPEG quality to that. But there's also the possibility to adapt the JPEG level to the network performance. Because as I discussed at the beginning of my talk, I'm on mobile right now, I'm going through roaming, so I'm not the primary customer here, which means I get bumped back to 2G a lot. So when I'm on 2G, I have lousy connection, but I still want to read news articles and stuff, and I don't want to wait for them to load for 3 minutes. With detecting the network performance for me, a website would be able to ship a low-resolution image to me, which is still acceptable, and which renders fast. You can do this using the HTML5 navigation timing API to detect the network performance of your current client and then ship highly compressed versions of an image to those customers which have poor network connection. Or you can use a platform like Akamai to do this. We optimized that too. So that technique is called AIC. You can Google for that and find out how to build that. So create different quality versions of an image, find the network performance of your end user, and ship different versions depending on how good or bad the network of your current client session is. It's a very smart technique. Okay, so now I talked a lot about what JPEG is able to do, but there's still things that JPEG is not able to do, namely transparency. Big problem. Everybody wants to use transparency. Lots of e-commerce stores we've been working with, they use transparency in their images, especially with bottles and stuff. They want to put backgrounds behind those. So transparency is still a big issue. And there's a ugly workaround, which I still think is super cool, that can make JPEG do transparency. And that is nested in an SVG container. Who has heard of the clown car technique for responsive images? 2 people. Oh, damn. Okay. So the clown car technique was used to create responsive images before responsive images were native. Very, very cool. It was a SVG container with different JPEGs inside, and because you could do media query detection inside SVG, you could switch out which kind of image to show. Nice hack. Zorro SVG for alpha transparency works quite the same way. You put the JPEG completely unintuitively inside an SVG container. Then, with the Zorro SVG tool, you generate an alpha transparency mask, and with an SVG filter, subtract that alpha transparency mask from the JPEG and get a full alpha transparency image. because of the SVG filter. You have the benefit of a highly compressed JPEG, very, very neat, and you have full alpha transparency. Only problem you're going to be facing, aside from the fact that the SVG filter takes a couple of minutes, a couple of milliseconds to render, is of course that you have to have SVG support on the client device. So Android 2 is out, for example, which might be a problem depending on your client base. So this is an ugly, ugly hack, but here's the good news. In the future, everything's going to be better. Again, like Hillary said, the future is awesome. There's JPEG XT coming our way, and you might say, well, there was JPEG XR, who the hell cares about JPEG XT? The thing is, JPEG XT is not created by Google or Microsoft or any other entity trying to push a new format out there. JPEG XT is created by the JPEG working group, the same guys who created JPEG in the first place. And the good thing about JPEG XT is it's going to be backwards compatible, which means every browser since 1995 will be able to render an image, which clearly WebP wasn't able to do. So that's all good news. And JPEG XT will be able to do it all. Again, it will have 8-bit support, 16-bit support, 24-bit support, full alpha transparency, etc., etc. The only thing that it will not do is animation. But everything else, JPEG XT will solve for us. And because it's backwards compatible, we won't have a problem with it, which is great. And this is also good news. It also outperforms all the other tools. Again, very, very good compression, being smart about how to optimize the image. So JPEG XT is coming our way, and that's really, really good. So I want to leave you with takeaways, what to do when you leave this room today. Number one is, because I've been talking about it all the time, use mods JPEG. Really, don't use Adobe Photoshop, Safer Web, or GIMP, or any other compression tool. If you're working with JPEGs right now and put them on the web, put them through mods JPEG, because it's the best encoder out there right now. And then if you still have the problem that your images might be too big, think about salting your mods JPEG with tools like CJPEG DSIM for dynamic quality adaptation. Or if there are hero images and you must, for all intents and purposes, avoid compression artifacts, run them through Adapt to adapt quality setting per tile size. And then, second one, keep it up to date with JPEG XT development. It's being developed right now, and the discussion is still ongoing. But it's going to be out soon. I think 2016, end of 2016 is probably likely. And deploy it ASAP when it's out. Because, as I said, it's backwards compatible. It's going to be able to ship the traditional JPEG inside its new JPEG XT container. So all the browsers will be able to display that. And when you do mods JPEG right now, you're going to enable all your users to download images faster. And in 2016, when a JPEG XT is going to come out, you're going to be able to compress them even more and have all the benefits I've been mentioning. So thank you. That's all. And yeah, if you have any questions, hit me up. Ah, I knew that one was coming. Cool. Any thoughts on the FLIF format? Yes, cool, don't use it. The reason being, every format that is not supported by all the browsers needs polyfills, and polyfills take too long to process. We've done some internal testing, and while JavaScript is, I think, on a 100th of the performance of native C right now, it's still not fast enough. So the discussion is that maybe in 4 or 5 years, JavaScript would be able to be that fast that we would be able to polyfill stuff like image processing inside the browser. That would be really cool and also kind of scary. But right now, don't use it, because if you use an image format like that on the web, you will just create a bad user experience for your users because they need to have JavaScript enabled, and it will cause the delay. So. That's an academic discussion. So FLIF is really, really cool. Oh, sorry. Okay, so the first question is what was about FLIF? What's about FLIF? And now the question is disregarding the real world. Pardon. What about the abstract features of FLIF? And the truth is, it's an amazing format. It's really, really good. I like it a lot. It does a lot of things right. Still, I think you always must regard your use case. So if you're only interested in storing images on disk, for example, as small as possible while keeping quality as good as possible, Image formats like these are great, but if you want to ship them to users, no.
Okay, so thanks, Tobias. We will have some more time later today where we can have some more questions to Tobias because we're running out of time. So we have, I think, 3 minutes break, and then it will be Barbara. Thank you, Tobias.
Thank you.
Okay, so it's time. So I'm very happy that we are having Barbara here today from the Mozilla Foundation working for Firefox Mobile, right?
Yep, that's right.
But today she's going to give us some tips on how we can make our websites fast. Thank you.
Thanks, Peter. All right. So yeah, welcome. Today I'm going to talk to you about the book that I wrote this year. But first, I want to draw some attention to how great I think Stockholm today at the ABBA Museum. And I hope that says hello, friends. I hope that's the translation. Don't make me say it. Only after a few beers, maybe tonight. A big thing is I want to kind of point out that we have a disclaimer here. So what I will be doing today is probably I will say a lot about, well, you can read more about in this book. And why is that? Well, because I want to make the big bucks, right? That's why I'm here. I want to sell the book to all of you guys. No, joke aside. It's just too much work. It's just too much content, obviously, to form into 30 minutes or 40 minutes. So there wouldn't be much value in buying the book if I could tell you or read the book out in 30 minutes or 40 minutes. Is it worth the money to write a book? Not sure. I don't think so, or at least not yet for me. So what I did here, in case anybody ever wanted to write a book, I used GitHub to commit all my edits, and this is Git stats, and it kind of shows you how I was writing, and that's pretty much what I also had set up to do. So it took me about 240 days to write it. You can see that most of my writing was done on a Tuesday. I didn't plan that, but I guess that's how it went. So those are basically the commits that I made. And then you can see, and that kind of goes back to what I always had planned, is I most of the time I wrote before work. So you can see I committed between 8 and 9 o'clock in the morning, because that's, again, where I wrote most of the time. And obviously a lot of weekends reading. That's enough about that. Let's start with the first part, which is you want to start within the company to shape performance culture. So it's not necessarily that we're diving right into the code right now and to look for performance, but it most of the time starts with the people who make the decisions, right? You get maybe marketing to tell you, well, you should put this ad in or whatever, and then you have to kind of argue around or figure out how much that influences your website. But how do you shape a culture of performance? First and foremost is you have to make everybody aware and care about performance, because it's everybody's business. It's the designer, it's you, the developer. I assume most of you are developers, product managers, content strategists, all those people. You also should feel empowered and encouraged to say no. So if there's something that comes your way that you have to implement, don't feel shy. Don't think you cannot say no to it. At least rather, argue or show what the impact could be. And I'm going to show you what I call a performance point system later on that helps you, especially talking to designers and talking to people who might not know a lot about code. And of course, once you've actually gone to a point where you've made some progress and some success, celebrate it. Etsy, textbook example for pushing and forming performance of culture. What they do is every month, they list or announce a performance hero. So somebody in their team who did something really great that could help them be faster. They also sell performance hero stickers on their Etsy page as well. And what I really like is they're very transparent. And that's not only good for all of us to see what they're doing, but also for them, because you have some sort of a guarantee to quarterly bring out a report that says, hey, we've gotten faster. So it's a very good focus and a very good idea of, as I said, not only getting your stuff done inside, but also being responsible for the public to show that. The magic formula in my mind is performance is perception and respect. So perception is not really what we can change, because we all have a very subjective perception of speed and the world that we live in. But we can control respect, I find, because the greater respect you show to your customer or to your users, the more likely they experience satisfaction and are happy. So show respect to your visitors by avoiding any unnecessary delays to your website. And I believe and I hope each of the websites that you create or deal with, they should have a goal, right? So most of the time you want the user to perform a task on your website. So maybe even start with counting the steps, how long it takes somebody to get the schedule of the train station or put something in a shopping cart. That's a good start as well, and start discussing with your user experience team. And ideally, treat speed as a feature. That's, I think, should be part of our daily lives now. Also optimize from a user's perspective. We all sit probably in offices that have really, really high-speed internet connections, and you load a page and it looks really fast, and you're like, hey, that's great. But look where your users are coming from. They might not have those high-speed internet connections. Use RUM, which is real user monitoring. This is also explained in the book, so here's my first shout out. You should read the book, then you know more about this. And let's start with the first step, which is normally wireframing, right? So you have your designers at wireframe. Let's start with wireframing for performance. So here I'm going to introduce to you the performance point system. Again, this is explained in more detail in the book. Not every designer is a coder, and that's totally fine. They don't have to. So you have to kind of find a way to bridge between those two professions. And I've noticed a lot of the times that you need to make sure that designers understand performance implications. So let's start with this example. This is taken by Web Page Test, a great performance tool that helps you visualize how long it takes for different steps to load on your page. So I took time.com as an example. So this is, a time.com landing page. We have the hero image. We have, some stock ticker. We have some video on the right side, and some ads at the left bottom. Let's reverse this back into a wireframe in our minds and in our brain. So when you slowly go back, that's what I did. So you can see that, we have above the fold, then we have the stock ticker, we have, an ad. So I kind of, as I said, reversed this. And then I looked at what kind of things start loading after 3 seconds or, based on that film strip that you saw at the beginning, after 5.7 seconds. So slowly everything comes in that the user can see. And after 7.5 seconds around that time, we're done. So if we look at all those graphical elements that you saw on the page and how they're being loaded, you can kind of guesstimate how long it will take for certain items of those elements to load. And you can correlate that back to the performance impact it has. So what I did here is I kind of tried to separate those elements into low impact, meaning small images, stuff that loads fast, then medium impact, give that points, in this case 2, medium-sized images, simple scripts, and then the bad ones, the high-impact ones, which are large images, third-party scripts, a lot of stuff that you either have influence over or you have to just pay attention to. So as you can see, what I did here, I used a bunch of different shades of gray. So it's not 50 shades of gray, it's just 3 shades of gray. So we have the big image is very large. We have the ad. All that stuff has high impact, so the dark gray. Now what I did is I circled the order in which they're loaded. So this is what you saw at the beginning. You have 1, 2, 3, 4, 5, so all over the place. But you would think certain elements of your page, especially above the fold, are very important to load first, because I assume breaking news, you want specific things of your website to load right away, and not necessarily, the magazine specific, the number 2 here. So with this performance point system in the NPM, you can probably get a better agreement and understanding with your user experience team, what needs to go above the fold, and then prioritize based on that. So here's a suggestion. So you have the menu, which is important because you want your user to browse right away. And then 2 would be your blurb and your image, because again, this is what you want to have the user read right away. And to have more of those exercises, I'm going into more detail in the book, so you can read that. Let's now move on to some code and some numbers. So measure first, then optimize, and keep repeating that. We've heard already about the performance budget, and I think that's a great idea. So the performance budget, what that is basically you establish a goal to work towards. So you set a baseline basically by comparing your performance result most of the time also to your competitors or to previous versions of your page. You can use Web Page Test, you can use page speed to do this, because I think it's very important to look at your competitors. As you can tell, the wise learn many things from their enemies. So again, an example I took from the book. I love shopping at, I'm not getting any money for that, but I love shopping at the Gap. Banana Republic and J. Crew. And as an example, you put those two websites next to each other, you use web page test, and all of a sudden you see huge differences, I would almost say. And there's also one thing which is called speed index. And that is a measurement or a value you could or should look out for to kind of compare yourself, not only necessarily the bytes or the time that it loads. So speed index was introduced by web page test in 2012. And the smaller the number, the better the site's performance is. The other one is PageSpeed. It's Google's answer to speed index. And here it's Google kind of says, okay, if you have 85 or higher, then your website is performing well. That's their assumption. Or Speed Curve, which is it's a very great tool. Has a I think a free version as well, but you obviously can pay for subscription as well. And Steve Souders moved there recently and is a big part of this company, and you can tell, or you can imagine, when Steve Souders is somewhere, there probably some great stuff coming out, so you should definitely check that out. Let's move on to the browser. So we talked about measuring, but it's definitely worth looking also how the browser renders a page. So let's look at this graph here. So rendering. Rendering is the process of displaying the requested content in the browser window. So that's the primary function of the browser. You have HTML, you're parsing the HTML, and that leads to the construction of the DOM, the document object model. And it's a tree structure that describes the elements of the page. And then you have CSS at the bottom, which is render blocking. So the browser needs to load all CSS files prior to rendering the content. And then we have the CSS OM object model. And the browser also has to process the style sheets in order to understand how these elements in the DOM should be displayed. And refer to this, as I mentioned, to this CSS object model. And then JavaScript, which adds basically the power to manipulate and interact with the DOM. And then causing basically the render tree to change. In JavaScript is render blocking. So when used synchronously. So if you use it asynchronously, then you're not blocking the rendering. And I think Tobias had also mentioned stuff about that. And then last but not least is the render tree, or the render tree basically combines the content and style information of the entire visible content on the screen. Then we want to determine the critical rendering path. So we just described the rendering path itself, but it's very important to now look at the critical rendering path and what it is. So the critical rendering path describes the code and resources that are required to render the initial view of the page, or as you can say, the visible part, so everything above the fold. So I'm going to read a few of those slides because I don't want to forget too much. So let's start with number one. So on the left side, you see a very simple HTML sample page where I load, I just say hello friends, and then I have my hero image, and then I have a map that I load. So the browser begins to construct the DOM, and after it receives the HTML, after it has received the HTML. And that's also when the browser actually discovers the link tag, as you can see at the top with the style sheets, and sends that request to retrieve this CSS. And then number two, the CSS object model can only build when the CSS has arrived, which is why the CSS is render blocking. So the DOM building can't be finished because JavaScript has not been parsed. So let's look at that. Once the CSS arrives, the browser can build the CSS object model, which then unblocks the JavaScript. And now the JavaScript loads, unblocks the DOM to finish. And then the browser will merge the DOM and the CSS in the render tree. And finally, the browser can complete the layout and paint steps. Teaser alert again. So in the book, what I did is I created a very simple web page with a hero image and a bunch of dog images, and I kind of try to improve my critical rendering path. And there are amazing bookmarklets out there that help you to look through your page and kind of create CSS, inline CSS that you can then put in at the head of your website, and it improves the load time. And that's what I did. I have here at the top is without the critical rendering path optimization, and at the bottom it's with the critical rendering path optimization. And you can tell speed index already dropped by half, meaning it's very good because it's a lower number. And look at the start render time, because this is exactly what we wanted to do, right? It's the initial load, it's the critical rendering path. I dropped this to 0.7 seconds. And I think, again, this is not rocket science. I used a bookmarklet to do this. I didn't do much about this. If you don't believe me, you can see how it loads. You see it's way faster. So how do you determine your critical rendering path? So again, what can you do? The page itself is always a critical resource. So keep your HTML as clean as possible. Clean up your DOM by removing any unused elements. They just delay the rendering process. Order matters. Where you put things, don't put third-party features or scripts or web fonts in your critical path. Load only critical assets as early as possible. And then think about the 14 kilobyte rule. Who here has heard of the 14 kilobyte rule? Okay, good. So that means you want to serve the most important content first. And you need to do this within your first round trip that you're doing to the server and back. And we know that only 14 kilobytes of the HTML can be transferred before a new round trip. So you want to put as much as possible in that 14K that you have available. So in order to improve your start rendering time, that's what you have to do. So how can you do this? Focus on the above the fold content first, and load other assets afterwards. CSS is critical, as we said. Remove render blocking CSS. The most important styles, especially above the fold, they should go online. Unblock the parser by using attributes such as defer or async for JavaScript scripts, and in general, put the scripts, if possible, at the bottom of the page to avoid render blocking. Next one is reduce bytes. And you can tell by, as I'm going through those chapters of my book or how I focus on certain things, it's kind of, I'm following obviously the rules also that Steve Souders had put out there. So again, this is not super crazy stuff. Minify your page assets such as HTML and CSS and JavaScript. Biggest optimization results you can get, as also Tobias obviously showed us, by optimizing images. There's a good chance that you can heavily optimize things, use PNG, GIFs, or JPEGs, or SVG, or whatever it is, but at least look at it. There's a lot of optimization opportunities in there. And images are your best friend, but can also be your worst enemy. Avoid custom fonts. I'm personally not a big fan of custom fonts, web fonts, because again, they're very heavy and not done properly. They can also very much slow down the rendering time. Use gzip techniques to reduce the file size that is sent over the wire. The book also goes into some of the compressions and some examples that I did in comparison, and you can see what might work best for you in certain situation of the image. Reduce HTTP requests, not something you should ignore. Concatenate where applicable. So that means, what I think is always important is you should separate the more frequently changed code from the less frequently changed code. Concatenate files based on these criteria. And for certain ones that are not being changed that often, use a very aggressive cache policy, because certain files of your page will most likely not be changed so often. Don't blindly use JavaScript libraries and frameworks. I'm guilty myself. I think it's always very easy to just quickly plug something in and say, yeah, I'll just try it out, and then later on I'm going to change it or optimize it. Most of the time you don't do that. Image sprites always still something we can do to reduce HTTP requests. Data URIs, I've played around with data URIs as well, and I've seen some great improvements. You have to make sure there are certain criteria you should or you should not be using data URIs, especially when your source file is small, a certain size, you can do that. Fight latency, very important, especially also for mobile, which I'll go into in a second. So latency is the time that it takes for the content to be requested by and sent to your browser. And latency can vary. So it is affected by the distance the data has to travel and the medium that it conducts it. So you experience higher latency, particular, as I mentioned, on mobile networks. And why is that? Because the radio of your device needs to first find the closest tower to basically communicate and establish a connection with first. And if the device is idle, it even can take longer. So reduce HTTP requests as much as possible. The highest latency occurs on mobile devices. Reduce the amount of polling on your page. So don't constantly try to fetch new content if it's not really necessary, especially if it's not immediately needed. And the 14 kilobyte rule, send the most important styles down the wire as soon as you can. Remove redirects, because they require another DNS lookup, which takes another few hundred milliseconds. Keep a live header. That is a very good header you can set as well to keep TCP connections open. Offline storage, still probably a little bit, I still find difficult to implement or to use properly. Content delivery networks, that's the CDN, can be very helpful to speed up your website as well, because you basically move the requested resources closer to your user, and that's why you also reduce the round trip. And HTTP2, and I think Andy is talking about that later, which is a great improvement of the web, which was formerly called Speedy, and you should definitely check out his talk about that as well. Make friends with the server, or at least have somebody who knows how the server works and how to manage it. gzip is you can use to have uncompressed assets such as HTML and XML, JSON, and CSS. Very easy. There's an HTML boilerplate setup where you can get your server config files are all set up in that HTML boilerplate, which you can find on GitHub as well. And literally what I did here is I just literally add another line in my web server config file, and all of a sudden gzip was enabled. And you can see also here again what a great difference it makes by just adding something small like this to your configuration. So don't miss out those small little opportunities. They give you so much great impact. And cache. So create a solid cache policy. Use conditional requests, so content-based or time-based. So depending on what kind of content you show, should be more heavily cached versus content that needs to be fresh. Then time-based also. Certain things, don't change too much. Obviously, the cache doesn't apply to new visitors, so cache only hits when you're a reoccurring visitor. Here, as an example, also from the book. So this is you can set this up if you don't have all the server rights on your server. You can just create an htaccess file. What I did here is I have a horrible WordPress blog, and a lot of the times all the content changes, as in like blog posts, but for example my hero image or my style sheets, they probably don't change that much. So what I did here is I think I normally write maybe every 2 or 3 months a new blog post. So I could set that main directed 2 months just to be on the safe side. And for example, my uploads, so my images or PDFs that I put in that blog, they rarely change. So I set it to a year. So again, this is just an example. You figure out your policy on your website and assets that you have, how frequently those change. But again, here you see load time, start render time, speed index, all that stuff improved by just adding a bit of cache intelligence and cache policy to it. Also, you just have to take the time, think about it, set it up, and then it's done. And tame the mobile beast. Be respectful of your users' data, charges on mobile. Unfortunately, we still live in a world of roaming where companies take a lot of money from us if we roam on a different country. So don't make the user pay for your bad performance. That's just not nice. Also think about different mobile strategies. You've probably heard of responsive web designs, the M-dot, scenario. Then REST, responsive web development, server-side components, so you do like a combination of that. Or what I had done in the past also, REST with ESI. ESI is something, it occurs at the edge of your content delivery network, and it's faster than putting the stuff in front of the user. Yeah. Remember, mobile devices are powered by batteries. So if you have a lot of JavaScript, a lot of big images, it will drain the battery of your users. They might not want to visit your page because they have too much stuff on it. And your competitor's website is, way lighter when it comes to batteries, because we all face the challenge still of our mobile devices not probably lasting a day. Consider offline storage techniques. And also test your mobile experience on real devices. Also something I find, ignore, because we just quickly test again in our office with a high-speed internet. Oh, it looks good, it loads fast. No, not really. Look at the real user monitoring or your data from your users, and see with what kind of bandwidth and connections they come onto your site. And automate your performance routines, which I think is great, and I love it. I've used task runners such as Grunt and Gulp. You probably heard some of them before. Those help you in not worrying too much about certain things, but rather automating them based on looking, through the code. You can apply filters and even warnings. eBay has done a great, I think, eBay, they have a continuous integration plugin or a continuous integration tool created that when you do certain things to your web page, such as maybe including third-party scripts, and you're not doing it the proper way, the continuous integration fails and you can't build further. So the continuous integration encouraged the developer to actually fix their issues, also specifically around web performance. And that's what I did as well. So in the book, I'm going through a complete example of having a very dumb website with a lot of bad stuff in it, not optimized images, bad script tags, loading certain things not properly in terms of the rendering path. And when you actually plug in Grunt and let your website build, it optimizes all of this for you, concatenate scripts and all that stuff. And again, here you see without magic and with magic. Obviously, without magic would be the old one. I might have not increased the page speed score so much, but you can see when you start render time and the fully loaded time, I improved some stuff there as well. Again, this is not, I didn't have to manually do anything. I just let it run, a tool run on my website to improve that. Avoid the yo-yo effect, which is basically, right, you lose weight and then you gain it right back. And that's a very common thing of especially diets. So I kind of see that the same happening for web performance as well and big bloated websites. And in order to avoid that, you should constantly measure and monitor your stuff. I had the pleasure, or maybe not pleasure, when I was working at the CBC, the Canadian Broadcasting Corporation, we had this happening where everything was going smoothly. We had like 5 or 6 seconds load time on the mobile website, and then all of a sudden there was a spike, and we encountered, I think, 10 seconds of load time. So we got a warning And then we investigated, and thankfully we were able to pick that up very quickly and find the error, remove the error, and everything was good. So if we hadn't had those warning mechanisms in there, we probably wouldn't have had the chance, and we would have gained that weight back. All right, and I think this is kind of, I want to leave you with a quote that Larry Page, so one of Google's founders, said, and I think if you kind of use that every day when you build websites to think about that, I think it gives you good inspiration and encouragement to get faster. So unfortunately, because I was traveling and I only have 21 kilograms allowance, baggage allowance, I could unfortunately not bring too many books with me, or at least not, well, just one for Peter. So if you, oops. So if you wanna, and I apologize that I couldn't really bring any books. So there is a $25 off ebook discount that you can apply. So if you're interested in the book, and if you want to buy it, and that's the last sales pitch that I'm making today, you can go to Lean Websites, bbinto.me, and you can order it from there. That's it.
Any questions?
Is Mozilla eating its own dog food? So is Mozilla keeping its websites fast and lean?
Yes, of course. That's what I have to say. No, what kind of websites are you? Just like Mozilla.org, like all those standard? Yes, like they're. I mean, I haven't checked it since I started there because I'm working on the mobile stuff or the browser itself, not the web pages. But I can tell you from the inside when it comes to performance and making also the browser fast to allow, to support all those standards that help you to get faster. Mozilla and Firefox is heavily working on that, yes.
Anyone else?
Culture, I always think culture is hard when I'm a consultant, I come into a project, nobody speaks about this, everything is really bad. How long does it take to get people to get it, to actually work for it?
Obviously that's an important and heavy question, right? I think I've noticed at the companies I work that convincing people, most of the time it's sharing, things like that. I think if more people hear about it, the better it is. Showing examples and saying, hey, if you care about performance, there is a benefit for your company as well, because especially I think there are great research studies and great articles done about especially e-commerce websites that, even if Amazon has whatever 1.5 seconds faster load time, they make so much more money based on that. So it's again, you put a dollar sign to it, and then you'll probably get the managers to say, yeah, okay. So find those. I think you have to be smart about it, and you have to find those nuances how you can convince management. But it's not always like I'm not saying this is easy, and you can't get it done by tomorrow. So. What
about tips for convincing
designers? I would
Can you repeat that question?
Oh yeah, what should be done for designers? How to convince designers? I personally felt the example that I gave with the performance point system that really helped for me at the CBC where I work. That designers got a better sense of, oh, okay, so you're telling me if I add those 15 huge, large images to the page, which looks amazing for the user if they have a fast internet connection, that way. I'm hitting a bad performance impact, then I think you reconsider. So I think it's that wireframing stage that you say, tell your developers, or the developers tell you, work with them. Think about the things that are very important at the top of the page, above the fold, and get that sense of, okay, if I put this, if there is a big hero image, either keep it in but optimize it. versus maybe make it smaller or something like that. So again, I think just talking to developers and saying, even if they're not aware of performance implications yet, just say, hey, what do you just start the conversation? What do you think if I put those 15 images above the fold? Do you think that's okay for performance? And then this person, the developer, can probably go ahead and say, let me prototype this quickly and see how long it takes to load, as an example. Yeah, definitely. So the question was, or the comment was, if you have a more performant website, automatically your server load and your all costs that are related to even hosting a website will go slower. So of course that's a good argument to have with a manager as well. I mean, nowadays, unfortunately, servers, it's very cheap, right? So even if you have a lot of data loaded to them, it probably doesn't increase too much of the fees maybe you have to pay. But still, at the end of the day, performance is nothing bad. Being faster is always better.
Okay. Thank you, Barbara.
You're very welcome. So you can all go to lunch earlier.
Oh,
That was
so we have a couple of more minutes, and if it's okay for you, Tobias, do we have any more questions for Tobias? Because I can start first, then. Yeah. Okay. So in your talk, how do you think we should do? Like, we are running a CMS, and what's your experience of? So I see we can use the tools you proposed, like if you're publishing your site manually, but how do you have any experience of using it in a CMS, or like how do companies do?
So for the most popular CMSs, there are plugins to do image optimization via user upload. The biggest issue that people have with image optimization tools is that they're not instant. So I've seen lots of tools being dissed because they're not fast enough. So they take a couple of seconds to process, and then users complain, "Oh, well, I can't show the image instantly after it's being optimized." But the thing is, all you have to think about is an asynchronous queue in that case. So when an editor or somebody in a CMS uploads an image, just put that into an asynchronous queue, put that on another machine which can do the optimization for the editor. Show them the unoptimized image for their session. They don't really care. It's just the editor review. They're not a user to be converted. And then just show them the image uploaded uncompressed, because they can work with it now. But then when the image is optimized from the queue, replace it in the background. So that's nothing an editor needs to be exposed to. Forcing your editors to optimize your images manually, for example, that never works out. It's always the human. The human is always the error in the thing. So I'm always going for optimization, but make it undetectable. So don't make a user wait with a spinner for an image to optimize, but just give them a good user experience of, yay, I've uploaded this image, now I can continue working, because they're not they don't want to. The task is not uploading an image. The task is edit content. So you have to give them the good user experience that the image is there and the upload is successful. Give them a nice green checkbox. But at the background, have an asynchronous queue that does the work for them, so that everybody but the sysadmin can forget about the process being there.
Thanks. Anyone else?
Hi, one more question. What kind of experience, and this is to the lady, spend efforts on server work versus client or the application itself, like upgrading your PHP version, upgrade your database, or work with the application itself? Do you have any feedback on where you can make the most gains?
I'm not a server person, so I I know that you can do a lot on the server to optimize, even the little few examples that I gave you. So I think most of the stuff that I was focusing on was front end. So anything obviously from, hitting the browser to rendering for the client. But yeah, I think I'm sure that there are database queries that you can optimize. I'm sure that there is, I guess, certain PHP versions that you can install and load. But yeah, I don't think I'm the expert in giving you a lot of advice there.
Okay, thank you.
Welcome.
Okay. So then in a couple of minutes is lunch, and then there's the lunch keynote, and then it's back here, and we will listen to Andy that will talk about HTTP2. So thank you. So, okay, so now it's time for Andy Davis, and he will talk about HTTP2. And Andy, he's like the web performance guy of Europe, the most known, I guess, or something like that. But he also wrote a book, or a co-writer of the book called Using Web Page Test, and that's really interesting because web page test is one of the best web performance tools, and there's not so much documentation on it, so the book is actually really good. So, Andy.
Thank you, Peter. I don't need a round of applause. Okay, so I'm Andy. I work for a web performance company in the UK called the NCC Group. We mainly deal with retailers and financial services companies. And I've been tracking the performance or the impact of things that like Speedy and HTTP2 will have for quite a while. And what I'm going to do today is share some of what I've learned, some of the questions my clients are asking. And if you've got any questions at the end, just feel free to chime in. I'm on Twitter like everybody else, so you can tweet me questions as well afterwards. I'll put the slides on SlideShare, and there'll be my email at the end. But as Peter said, yes, I wrote Using Web Page Test with Rick Viscomi and Marcel Duran of YouTube. And a few years ago, I wrote a short book on web performance that you can buy for a cup of coffee. And it's a 45-minute read. And that's the end of my book plugs. To talk about HTTP2, first of all, we need to take a step back in time. And we need to take a step back in time to 1999. Should we keep going? Is that a fire alarm? Oh, it's gone, okay. So,
Viktigt meddelande. Viktigt meddelande. Brand har utbrutit i byggnaden. Lämna omedelbart byggnaden genom närmaste utgång. Använd inte hissarna.
Probably, yes, sorry.
So, welcome back. Wasn't it nice and warm outside? Some of you lucky people even have coats. So, to recap, I'm Andy. I work for the NCC Group in the UK. About 20% of our business is web performance, so retailers, financial services, that sort of things. I was really interested in Speedy when it first came out. I've since, as the protocol has moved on, I've got increasingly interested in HTTP2. And what I'm going to spend the next 40 minutes we have now, we might run into the break, talking about is what's HTTP2, why do we need it, what does it mean for our customers and our websites. But first of all, the inevitable book plug. As Peter said, part 1 before our interlude. I wrote Using Web Page Test with Rick Viscomi and Marcel Duran of YouTube, and a couple of years ago I wrote the Pocket Guide to Web Performance for 5 simple steps. Go buy them. That's my plug over. But if we're going to talk about HTTP2, first of all, we need to take a step back in time. And where we need to take a step back in time to is 1999, when Google was 1 year old. If you're old enough to have been working in technology then, you were probably working on one or two things. You were probably part of the panic to fix all the dates in all our mainframe applications before Millennium Bug came along and broke everything. Or you were part of the dot-com boom and you were one of those early poster childs working on the web, exploring this new frontier, probably over your AOL dial-up connection. But the other thing that happened in 1999 is RFC 2616 was standardized. So HTTP 1.1 was standardized. It wasn't the first time it was standardized. It was originally standardized in 1997, but we finally settled on a version that lived for the next 15 years in 1999. And the web of 1999 isn't the web of today. This is Yahoo that I pulled from the HTTP archive. And as we can see, it's very different to modern websites. It's mainly text. There's a few images for Visa, the ad banner, no CSS support, fonts were done using the inline font tag. And the web has changed tremendously since 1999. Yahoo still looks roughly the same. We can recognize it as Yahoo. Apart from it has more images, it has richer typography, it's a more sophisticated layout. And if you look at the HTTP archive, you can see that our websites have got increasingly more sophisticated, more resources on them, more scripts, CSS, more content coming from other places. But we don't just have documents. We've moved on to a web that has a rich level of interactivity. We have spreadsheets, word processors, real-time things like the Facebook feed or Twitter, where we're trying to do much more with the web, much more over HTTP. And that poses some challenges for us. Because TCP, which is the fundamental building block that HTTP runs over, HTTP can run over other things. There is a standard for running it over ham radio, for example. But the reality is most of our HTTP happens over TCP. And there's a bit of a mismatch between what TCP is good at and what HTTP requires. So TCP was built for reliable delivery of large files over long distances. And the web's not made up of that. Our files may come over long distances, but the web is made up of lots and lots of small components. So we don't use, HTTP doesn't use TCP as efficiently as it could. And what we've been doing is we've been hacking around some of these limitations, perhaps not realizing the implications of the hacks we're making. For starters, we have this thing where each TCP connection can only support one HTTP request at a time. Until that request is finished, that TCP connection doesn't become available again. If that connection's slow, if that request or response is slow, then that connection is tied up for that time and can't be used for anything else. So we hacked our way around it. What we did is, in the initial spec, browsers were only allowed to use 2 TCP connections to make 2 requests in parallel. And then Firefox discovered that if they upped that limit, pages loaded faster. So we went from browsers that could only make 2 parallel connections to ones that could make 4 or 6 or 8. And IE11 under some circumstances makes something like 11 or 12 or 13, I can never quite remember. But that wasn't good enough for us. So what we started doing is splitting our requests across more domains. So this is the BBC from a few years back, and they split their content across 4 domains. So instead of, if we've got a browser that can make a maximum of, say, 6 connections in parallel, all of a sudden, we've got 24 connections in parallel that we can be busily downloading things over to try and make efficient usage of the network. But when we do this, we override some of TCP's mechanisms. We override its congestion control mechanism that it used to determine what's the optimal amount of packets it can send down or send across the network. And we run the risk of congestion, of things like our router buffers filling up, so dropping packets. And we run into the risk of packet loss. So sharding multiple TCP connections delivers benefits to a point in time, but then it gives us danger. We can run in situations where it actually makes our performance worse. And Will Chan, who was of the Chromium team at in the past, wrote a blog post talking about how Etsy sharded across 4 domains and how they were running into packet loss situations so that actually they were sharding across too many domains and it made their performance worse. So not only do we do these things to override some of the mismatch between HTTP and TCP, every HTTP request comes with an overhead. The most fundamental overhead is the overhead of latency, where how quickly we can send a request to somewhere and get a response back is governed by the speed of light. Network packets travel at roughly 2/3 of the speed of light down a piece of fiber optic. And that means it also matters how far away from us our servers are, because the further they are away, the longer our pages will take to load, the longer our packets will take to come back to us. And Mike Belshie did a study called More Bandwidth Doesn't Matter Much, where he looked at the relationship between latency and bandwidth and what implications they had for how quickly our pages load. And as we can see here quite clearly, there's a linear relationship. As latency goes up, our page load times get longer. There's another aspect in that with every HTTP request, we send our headers. And our headers often contain lots of repeated information, like the user agent string will be the same for every request made on a web page. And although we can do things like gzip the content that we send over the wire, so gzip the HTML or the CSS or the JavaScript, that only affects the body of the content we're sending. The headers remain uncompressed with all their duplicate information. And then the other thing we do is TCP, as part of its congestion control mechanism, has something called the congestion window. And what that is it's how many packets a server is allowed to send to the client without waiting for a response. So what happens is typically a server set up with an initial congestion window of 10. So that means when it gets a request, it can send 10 segments in return. If those are acknowledged, then the congestion window grows. So the number of packets it can send next time increases. If there's packet loss, it decreases. But what that means is if at any point we have small files that don't fill the congestion window, then we're wasting the bandwidth. We're wasting the opportunity to send more packets. In this case, we've got a response that's 3 segments, and we could have sent 7 segments more. So we've sent somewhere around 4.5K. We could have sent 14.5. So to overcome this, we follow recipes. We follow some of the recipes that Barbara mentioned earlier on that Steve Souders came up with. And we follow these recipes without always being aware of what that means or what the implications are. And one of the recipes we follow is to bundle small CSS files together or bundle small JavaScript files together to make them more efficient to download. So they fill the congestion window. So we get rid of the overhead of the latency in the request and the response. So we get rid of the duplication in the headers. But that comes with implications. We give the browser more to download, whether it needs it or not. And if we change just one part of that bundle, it becomes invalid. The browser can't use it anymore. It has to download it again, or a proxy cache has to download it again. We do similar things with images. So we take all our small images and build them into sprites, because lots of our small icon images are only a couple K. So we build sprite sheets. But then to get just one image, we have to decode the whole sprite sheet. And what that means is the browser will cache the whole sprite sheet in on disk, or disk even on a phone. But every time it wants an image out of there, it may have to decode the whole sprite sheet. You know, it will keep it in a memory cache, but if that memory cache, if memory gets tight in that cache, it may have to kick it out. And then if it comes to needing it again, it will have to decode it again. The other thing we do is we override the browser's priorities. So all modern browsers use heuristics to determine what order they should download things off the web. Most of them will prioritize CSS, where the media query matches. Then generally JavaScript. If you look at a waterfall these days, you'll often see that even if you put your JavaScript at the bottom of the page, the browser's requested it quite early in the waterfall because it's determined it's a critical resource. So the browsers make these choices for us based on the massive amount of pages they see. They use telemetry to send it back to make decisions on what's the optimal way to load a page. But every time we do things like embed some binary data using a data URI in a CSS, we're overriding those priorities. I'm looking at a client now where they have something like 34 images embedded in their CSS as data URIs. And what that means is that CSS is bigger. When it comes to rendering the page, it means the CSS will take longer to download. So the visitor will have to wait longer for that page to start to render. Whereas if these were normal images, the browser would make a decision on when it should use them based on its own heuristics. The other thing we do is we inline critical resources. Like this is a bit I stole from a guy named Yoav Weiss's blog. He implemented the picture element in Chrome, so we all owe him a big favor. But we do things like take the CSS, work out what's critical, work out what we really need to render our page, and embed it in the head, which gives us some maintenance problems going on. And what all these techniques we use to speed up our pages show is that there's a tension between development and delivery. As developers, we think of code in modules. We modularize our code, so our components have a single responsibility. So we can transport them and use them in other situations. So we can encapsulate behavior in them so people only have to worry about their external interface. But that's not always the most efficient way to put it over the network. Or it's not the most efficient way to put it over the network. To put it over the network, we need to do things like combine them together and play around, perhaps overriding the browser's heuristics. And what we've been doing so far is using things like mod page speed, task runners like Gulp and Grunt, Broccoli, Plumber, however long the list goes on, to try and fill this mismatch, to try and make it easier to develop in a way that's efficient for us as developers, but then turn it into something that's efficient to deliver over the network. But what if we could use the network more efficiently? What if our network protocol supported us better in maintaining this granularity in production and enabled us to deliver efficiently over the network? And that's where HTTP2 comes in. And in common with everybody who stands on stage and talks about HTTP2, they show a video. And they show a video of HTTP 1.1 versus HTTP 2. This is the Go for Tiles demo. If it started playing. And as you can quite clearly see, the HTTP 2 version is faster. Akamai have their own version of this demo. CDN 77 built their own, and I'm sure there are others. But it's an impressive test, because this was done in 1.3 seconds, and this was done in 3.6. But the question I'd ask you, and the question I'd encourage you to ask of anybody who shows you a demo where he says this is faster than that, or she says this is faster than that, is it's impressive, but does it represent the real world? That image is made up of lots and lots of small images. We know in a HTTP 1.1 world, we can only make a limited number of requests at a time. So, and we know that making requests for small resources is particularly inefficient. So what we've got here is a test that actually we know is really inefficient for HTTP 1.1. And so HTTP 2 beats it. It's not a great test in my view, but we'll come on to some other tests in a minute and some real-world experience. But whenever somebody puts one of these in front of you, ask them to explain why it's a good test. So HTTP 2 itself, if you remember nothing else from this talk, remember the top bullet point, that from a web developer's point of view, from an application developer's point of view, the HTTP methods remain the same. So we've still got get, post, put, delete, head, etc. The status codes are the same. So 200 is still a success. 404 is not found. 500s are something is wrong with my server. And the whole semantics of how the protocol works remain the same. But underneath, things begin to change. So we've moved from it moves from a protocol where there were text-based headers in HTTP 1.1 to having binary headers. We can compress headers so that all that overhead of those headers starts to diminish. It's multiplexed, which I'll come on into in a minute. And also, instead of having the current HTTP 1.1 model, where it's always a pull model, where the browser asks the server for the web page, parses the HTML, sees, oh, I need this CSS file, asks the server for the CSS file, and the browser is always pulling from the server. The server can actually begin to say to the browser, you've requested this HTML file, you need this CSS file as well, before the browser becomes aware of it. So, waterfall from web page test. This is a HTTP 2 waterfall for the test page I used for this, and it looks pretty much like a HTTP 1.1 waterfall. The thing you'll notice is with HTTP 1.1, you'd expect far more of a slope like this, whereas we seem to have blocks where the browser sent a chunk of requests to the server and gets some responses back. But in HTTP 2 or H2, every request to the same origin becomes a stream. And streams are divided into frames. And in this example, there's a header frame. So the headers go separately in their own frame. And there's some data frames that essentially contain the response body for this request. There are also frames to reset a stream, push content, and various other ones. And because we're only using a single TCP connection, those frames are then multiplexed over that connection. So in this example here, the headers for stream 1 have already gone. But then we've got some data for stream 1. And then we've got the headers for stream 2 and some data for stream 2. And then we've got some more data for stream 1. So what we get is all these frames are multiplexed and intermingled across a single TCP connection. And this is what it looks like. If you ever looked at the bottom of web page test, below the waterfall, you'll see there's a TCP connection diagram. And this is the same site loaded. Top one is HTTP2, so we see a single TCP connection. Bottom one is HTTP 1.1, where we can see in this case there's 6 TCP connections. So if we're going to multiplex and mix these frames over a single connection, how do we know we're going to download the right frames first? How do we determine what our priorities are? And H2 has a prioritization mechanism that depends on weights and dependencies. And not everybody implements this yet. So Chrome, for example, implements the weights, but doesn't implement the dependencies yet. So what we have in this situation is we have the root object right at the top, and we have 3 objects, so 2, 4, and 6, that depend on it. And those are the 3 streams that get priority in the beginning, or right now. And the way they're split up is with a weight of 200, effectively stream 2 gets 2/3 of the band of the frames, stream 4 gets 1/3, and stream 6, that's at really low priority, effectively gets nothing. It will only get some time on the wire if the other streams become blocked for some reason. And then what happens is if stream 2 completes, then 8 and 10 will share its frames or share its allowance between them. So this allows us to build up quite complex models of how the server sends us content. And the other thing to mention about the weights and dependencies is the browser hints them to the server or expresses a preference, but the server is free to override those based on what knowledge it's already got. And there's some real challenges around this about what is the optimal order, what is the optimal priority, and just because we start out with those, does it remain that way? So we request a web page. First thing we're going to get is the HTML file. Does the frames for the HTML remain our priority for the whole point it's downloaded? Or at some point when we've got past the head and we start to need the CSS or any JavaScript that's in the head to start to render the document, do they become more important? And there are all sorts of questions like this out there waiting to be explored. We get header compression using HPAC, which helps just reduce symbol duplication. And there are plenty of illustrations. So Ilya Grigoryk's got some great stuff in one of his talks about H2, where he shows the header compression in a bit more detail. I chose not to do it here. So question is, does it make any difference? And so what I did is I took a template I found on a template site. It's not quite, it's probably not the best model of a modern web page because it's only got about 30, 40 requests on it, whereas we know modern web pages are a bit more complex than that. I hosted it on AWS in Dublin, and I tested it from AWS in Singapore using web page test and its cable profile. And if we hit play, you can begin to see that the HTTP 2.1 starts to get there sooner. HTTP 1.1 catches up. Then much better, and this begins to finish now, and this goes on till I think about 13 seconds. But if you remember, I said to you, if anybody ever shows you a comparison side by side, where one thing is faster than the other, you should question them. So you might say to me, Andy, I might host in Dublin, but my customers aren't in Singapore. My customers are in mainland Britain. Or I might host in Stockholm, and my customers are in mainland Sweden. So give me a more realistic case. And what I chose to do is do the same test with both the host and the test agent in Dublin. So they were really, really close together. And what we can see is HTTP 1.1 gets there a bit quicker in the beginning. Not surprising, really, because HTTP 2 has had to make a secure connection. It's had to do a TLS negotiations. It's had a bit of more overhead to begin with. Then, as we start to scroll on, we can see HTTP 2 sort of bit gets ahead, but they go in about the same time. But the advantage we've got is we've got a secure connection. We've managed to use H2 to overcome the overhead of the secure connection. But those are my tests. Some real-world numbers from the FT that a guy from Google talked about at Chrome Dev Summit is the FT are experimenting with HTTP2 on their next FT platform. And they've got a bit of a strange setup in that they serve their origin from Fastly, which isn't H2 capable, but they serve all their images and some other resources from Akamai. So based on a month's data, we can see that those people who are H2 enabled and using it are getting a faster experience. So we're beginning to see that in the real world, H2 delivers some of the promises. And this is just where they're using it as a straight like-for-like replacement of HTTP1. They're not using any of the new features that we can use. Or, sorry, they're not using some of the new optimizations that are open to them. And HTTP2 gives us some new optimizations and some new tools we can play with. And the first of those is server push, where what normally happens when we request a page from a server is we do a GET request for our root page and some PHP or some Java or something else goes away and starts building that page. And then when that page is built, get returned to the client, the browser starts to parse it, discovers it needs some more resources, and starts requesting them. But quite often, we'll know what resources go with that page. Our server sees people request that page thousands, hundreds of thousands, millions of times perhaps. So it can begin to learn. When I request page X, I need to send Y CSS with it. And Jetty has some of this built in at the moment. But what it means we can do is we can start to send the browser the critical resources. So the things it needs to render the page, like CSS or blocking JavaScript, before we've actually finished, build the page and send the page back to them. So then, once we've sent the CSS, the page starts to come back in its own time. There are some challenges in that the browser can reject the push. Say if it's already got it in its cache, it can issue a stream reset to say it doesn't want this. The challenge may be is the bytes may already be on the wire and being downloaded anyway. H2O, which is one of the HTTP2 servers developed in Japan, has this concept of something called Casper, which is cache-aware server push. So it uses cookies to try and determine what you'd already have in your cache to decide whether to push it or not. So there are people thinking about this problem, but how can we use push intelligently so that we only put the critical bytes on the wire? There are other opportunities, excuse me, for server push. So Barbara showed this diagram this morning about the critical rendering path for a browser, where we have to take the HTML and build a DOM from it. We have to take CSS and build the CSS object model from it. And then JavaScript may interact, and then we get to build the render tree. And it's only when we build the render tree, when we understand what styles are being applied to what elements on the page, that we begin to understand what background images are needed or what fonts are needed. And fonts are important because most browsers, or all modern browsers with the exception of IE, will wait for the font before they render the text on the page. So we'll wait for a web font before they render the text on the page. So if we can host the font ourselves or use an intelligent font foundry, then that has the option to push that font to us before we've discovered we need it. Multiplexing itself offers some other really interesting possibilities. And John Mellor of Google did a a study a few years ago where he compared parallel downloading, as in Speedy at the time, versus HTTP 1.1 as it behaved, to determine how much of an image, in terms of bytes, do we actually need to download to make a page usable. Knowing that in a world of H2 or Speedy, we don't have to download a whole image. We get it chunk by chunk. Whereas in a HTTP 1.1 world, we have no choice but to download the whole image because we're occupying that TCP connection. So this is essentially the simile for HTTP 1.1, and this is HTTP 2. And we can see already, just with 5% of the bytes of each image downloaded, that this page is looking like it's going to become more usable. When we get to 15% of the bytes, this looks largely complete. I can assure you it's not. I can assure you Mark Zuckerberg's a bit pixelated, and the man walking in the snow is a bit pixelated. We've got a really, really usable page. By the time we get to 25% of the image bytes, these images are pretty crisp, pretty clear, pretty usable. It looks complete to our user. And actually, the sequential version, so the one that's essentially HTTP 1.1, needs 80% of the bytes to match up. So by multiplexing, we can start to deliver usable content to the visitor sooner, even if they don't have it all yet. There are some questions over progressive images. So this study used progressive JPEGs because it's the only progressive image we've got at the moment. And there are some questions about how well people like it. But I think the real question we have to, or the real hypothesis we need to answer is a faster user experience better than some of the drawbacks that people feel they have with progressive images? So if we adopt HTTP2, the question becomes, is when can we kill off some of our existing optimization techniques? When can we start adopting HTTP2? And the interesting thing is that browser support right now is pretty good. Chrome supports it, Firefox supports it, Edge supports it without server push, I think. Safari 9 supports it without server push. So the browsers are getting there. The browsers are getting pretty good support. Server implementations are a bit further behind, but they've certainly come on a long way in the last 6 months. So we're seeing beta support from people like Nginx, although Nginx doesn't yet support server push. The current Windows Server technical preview supports HTTP2, and you can go and fire it up on Azure if you want to play with it. CDNs like Akamai and Cloudflare are looking at how they roll it out in a beta format to their customers. And even Apache now has a HTTP2 server module. So we're beginning to get to the point in time where we can realistically think about deploying this. But choose your server carefully. And I'll show you some examples of why you need to choose your server carefully in a moment. So does it respect the streams properly? Does it support the connection flow? Does it support the proper dependency mechanism? A few years back when I was doing similar research on Speedy, I did this talk using exactly the same template that I used to do the H2 stuff. And did this talk where this site was 30% faster using Speedy than it was using HTTP 1.1. A few months later, I went to do the same talk in New York. And all of a sudden, Speedy was about 25% slower. And what had happened is Chrome had gone from a situation where it decided on the priorities and ensured they were fulfilled by the server, to the point where Chrome hinted the priorities to the server and expected the server to fulfill them in order. And Mod Speedy on Apache just didn't pay any attention to those priorities. It just thought, oh, you want these resources? I'm going to pick them up off disk in any old order, and I'm going to send them to the client. So I had things like images arriving before my CSS. My critical jQuery that was in the head was somewhere part down the page. So if the server doesn't support these dependencies and waits properly, then you're not going to get an optimal experience. And implementations are still young. This is H2O. This is a waterfall generated from H2O 1.5, I believe. And if you look, you can see the request for the root page. But then if you look at the requests for the 3 CSS files and the 3 JavaScript files, and you can read web page test waterfalls, you might notice something odd. So green is the time between making the request and getting a response. And blue is the time it took to download the response. And to give you a clue, what happens is, even though these resources are being pushed in the order 2 to 7, what happened is H2O is actually pushing the font first, then the 6th JavaScript file, then the 5th JavaScript file, then the 4th JavaScript file, then the 3rd CSS, the 2nd CSS, and the 1st CSS. It was pushing them in exactly the wrong order that I wanted the browser to download them. This is fixed in the latest H2O, which is 1.53, but I'm seeing similar behavior in some other servers. Sometimes browsers do things you don't expect. So I was experimenting with server push and pushing CSS and JavaScript and fonts. I thought, great. The top ones where the resources are pushed, by the way. So look, 300 milliseconds improvement. Then I tested it in Firefox, and there was no difference between the 2 Firefox runs. I was talking to Pat Meenan of Google about it, and if we look at the waterfalls, we begin to see the top ones push, so we can see we get the HTML, and then we get the other resources really quickly afterwards. Whereas on the bottom one, there's a 300 millisecond gap in the waterfall where Chrome has just decided, I'm not going to do anything. I'm just going to wait. Probably eventually the preloader will start and it begins to download. So when you implement things like server push, check them in multiple clients. Check that the behavior is what you expect and there's not some unexpected browser behavior or server behavior influencing your tests. And one of the things is, if you're going to test with this, you need some tools. So one of the first tools I tend to use, because it's the easiest, is web page test. And one of the things you can see in web page test, and this is a Firefox test, I'm not quite sure whether it does it for Chrome yet, is if you're playing with server push, the fastest way to check it's actually working is run a test in web page test, and you can actually see that web page test tells you it was loaded by HTTP2 server push. But sometimes we want to dig into a bit more details than that. And this is where I find Chrome's net internals, part of the dev tools, quite handy. And what net internals does is you can go in there and it'll capture all network activity going on in the browser. So whether it's HTTP 1.1, whether it's HTTP 2, whether it's making TCP connections, whether it's doing DNS lookups. And you can either capture it locally in your own browser. You can run a test on web page test and generate the net log and download it. And that's what I did here. So I know we can start to do things like filter it. So we only see the HTTP 2 sessions. So we've gotten one here, and I've picked it. And then we can begin to see that, in HTTP 2 terms, we can see that this is where the browser sent the request for the page. And we can dig in more, and here we can see this is where the server, having got the request for the page, it's sent a push promise. So it's told the client that it wants to push this resource to it. We can see some bits where, when you see HTTP2 stream adopted, it's where Chrome matches up that push promise to a resource it wants, so it's going to use it. So by digging into Chrome's net internals, excuse me, and there's far more than I've shown there, because you can see where we're getting updates to receive windows, you can see bits, you'll see where you're getting headers, you'll see where you're getting data, you begin to understand how the server is actually sending those resources to you, whether it's prioritizing them correctly. By digging into it, you can get an understanding of what's actually happening and whether you're getting the behavior you want. There's tools like NGHB2, which has a proxy that I sometimes play with in front of Nginx, but it also has a client, so you can use it to request a page and see the same sort of things you can see in Chrome's net internals. So you can begin to dig in to whether the behavior is how you expect it. And as our servers and browsers mature, as they work more with each other, we'll begin to see some of these issues and some of these bugs squashed out of these implementations. We'll get to a more stable view. There's something called H2Spec, which is another tool by somebody in Japan whose name I can't remember, that allows you just to start testing your server. This, I think, I can't remember what server this is, but this was my server. Sorry, Tobias, this is Akamai. But these are all beta things. We're all learning and discovering and going through interoperability problems. And if you love telnetting into your HTTP 1.1 server to check it's still alive, you can use, I forgot what it's called, H2I, to query your server as if you were a client. So that's a stack of tools you can use if you want to get as nerdy as me and start digging into it a bit deeper. I mentioned at the beginning that HTTP2 HTTP2 doesn't rely on TLS. You can implement HTTP2 without TLS, but no browser today implements it without it. So being efficient at TLS is really important because, until we've done the DNS lookup, made our TCP connection, which is where our CDN comes in to make our TCP connection time smaller, and done our TLS negotiation, we don't get content from the server. And if you want to learn more about TLS, Ilya Grigoryk's page is TLS Fast Yet, contains lots of good information, but Ivan's book is probably the Bible. If you work on the web and you do anything with HTTPS or TLS, I would really encourage you to buy it. And the other thing is, as technology changes, as things like Heartbleed, etc., came out, Ivan actually updates the ebook version, so it gets continually updated. And then there's Ivan's project of SSL Labs, which is a testing mechanism, a grading mechanism for how well a site has implemented TLS, or how well they've implemented HTTPS. So it'll issue big red warnings. It'll grade you from A to F, I think it is. But if you're still using SSL, whether it's version 2 or 3, you're not going to get a very good grade. But it's a good way of sanity checking your TLS implementations. So we've talked a bit about servers. We've talked a bit about browsers. But as with any new technology, we have this bit in the middle. We have some people who are always going to be on yesterday's technology. So we have to serve HTTP 1.12. And the people who use modern browsers, who can use HTTP2, have HTTP2 enabled devices. And we want to try and deliver a good experience to both of them as we can. We might want to prioritize our HTTP2 visitors because perhaps they're the future. Or perhaps we're a different kind of store. Perhaps we're a store that sells more to people who are pensioners, who've retired, who tend to use older computers or older browsers. So our audience, our visitor audience, what they use will influence how we optimize. But there are some ways we need to balance out what we do. And fortunately, many of our good practices will remain the same. So things like making our content smaller to download, so it uses less round trips. So gzip compression of things like JSON, HTML, CSS, JavaScript, minification to shrink it further. Good image optimization, so our images in an appropriate size, will remain a good practice. Reducing redirects, because redirects are essentially just a waste. They're not quite a waste of time. They're a necessary evil, But all we're doing when we do a redirect is saying, Mr. Server, I'd like this resource. Server responds saying, no, you don't want that, you want this. And so we will always have redirects because our content will move, our sites will move. But we never want more than one. Doug Sillers from AT&T and I did a talk a few years back at Velocity in the States where we looked at the HTTP archive. And I think the worst redirect chain we found was 6 redirects to get to the actual response that the browser really needed. Effective caching will remain a good practice because if we can keep stuff in our visitor's browser cache or in a proxy server cache, then we don't have to make a request for it. We save on the round trips. We save on using that bandwidth. We allow other things to be prioritized. Reducing latency, so moving our content closer to our server, and reducing DNS and making less TCP connections will remain good practices. Others are a bit less clear. Others we may have to vary a bit, depending. So we should replace inlining content with server push and have servers that can intelligently push, have servers that can query our pages, understand the relationships between the resources, so we can start to push the appropriate content out to the visitor. We should start to think about reducing the amount of CSS and JavaScript concatenation we're doing. So they're in smaller files that are more easily cacheable, so that when one part of it changes, we don't invalidate it all. And we probably want to reduce image spriting, although there are some interesting problems with image spriting. So I was talking to Rick Viscomi of YouTube, who wrote the web page test book with me, and they were experimenting with how to change image spriting. And one of the things they found is they were using images for rollover behavior. So you hover over something with the mouse and the image changes. Now, the problem they were seeing in their experiments is they got rid of their sprites, they had separate images. So you download the image for the normal state, but when you go to the hover state, you don't have that image, you don't have a sprite anymore, that's a separate image that then has to be, the browser has to go to the network and bring it back. So there are some questions about, do sprites remain relevant for hover images, or smaller sprites remain relevant? I'd actually encourage you to use SVG, so you can style it with CSS and do the rollover that way, but there are questions about it. And generally we want to avoid sharding and splitting our content across all those hosts so that we allow TCP to keep control of its congestion control mechanisms. But HTTP2 does help us in one way, in that if we shard across 2 domains, which is all we recommend for HTTP 1.1 these days, so we split our content across 2 domains, and if those 2 domains refer back to the same IP address, they're protected by the same certificate, then what HTTP2 will do is coalesce those connections. It will merge them together and only use a single connection. It's great in theory. It's a bit harder in practice because if you're using a CDN, you don't know that those 2 connections are going to be routed to the same edge node. And with things like global load balancing, they may not end up at the same IP address. So there are some challenges around that. And this sort of brings me to, how do we move on? We've got to this situation where we know the optimizations we need to make for one protocol or for another, but we have a really diverse user bases often. We have people using old browsers, new browsers, fast connections, slow connections. And can we as developers or people who run our own servers, can we actually think of and put in place all the optimizations we need to deliver a great experience to people? Or are we going to have to rely on optimization services, such as ones based on mod page speed or Akamai's Ion, to deliver these things for us? will the amount of variety that we need to cope with just be too much for us? Or does HTTP2 actually make things simpler? And I don't know the answer to that question now. I think it's a question a lot of people are going to spend a lot of time thinking about it. And there are plenty of people with automated solutions out there trying to solve this problem. In my experience, some are more effective than others. And I think for some of them, I could do a better job by hand. But that's a different talk. But we've still got, even though HTTP2 allows us to make good use of the network, we've still got some challenges. We've still got things like people still use CSS at import, which means we don't discover we need some more CSS until we've got the first lot. There's a question about how they're going to fit into ES6 modules. There's questions about how is service worker going to cope with HTTP2 push that will all be worked through, and we will eventually get some sane answers on it. But the challenge that we don't seem to get through is our use of third parties. And if you look on any large commercial site today, we make massive amounts of use of third parties, whether it's for A/B testing, whether it's for analytics, whether it's for image delivery. And HTTP2 doesn't really help us with this problem. In the case of the FT, it does help them because all their images are on an image domain. But where we've got lots of little requests, and this one has got 160 requests, only 47 come from the origin, the rest come from various third-party services. HTTP2 doesn't help us with this much, but something called W3C resource hints should help. And what they do is they begin to give us ways and complementary ways of hinting to the browser what we're going to do. So if we're going to go to a third party, we can say, resolve its DNS ahead of time. Or in Canary, I don't think it's in proper Chrome yet, we can say, I'm sure I'm going to use this third party, make the TCP connection before I need it. And then what's coming along as well is preload, so we can say to the browser, look, I am going to use this resource from this third party, download it, here's an instruction. So there are ways of solving these third-party problems, but the amount of third parties we use on the web will perhaps limit some of the gains we can get from HTTP2. If you want to learn more, Ilya's excerpt from High Performance Browser Networking is available for free, and Daniel Stenberg, who is Swedish and wrote curl, has got a good explainer on the web. Finally, the thing I would encourage you to do is go and explore, go and play, go and learn, and share what you learn. Share your questions, share your puzzles, because it took us from 1999 or even 1997 to 2007 before Steve Souders wrote his book about how to make the best of HTTP 1.1. And surely we don't want to wait 8 or 10 years before we can make the most of HTTP2. Thank you.
Okay, do we have any questions?
Andy, I was wondering about domain sharding. Would you say that domain sharding is evil per se, or would it make sense in the time we're still dealing with HTTP 1.1 to go for domain sharding of like 2 to 3 domains, to have some domain sharding still available to the older clients, and only and take a little impact on the performance for HTTP2? So to basically serve both clienteles with one domain or with one setup, or would you encourage us to actually create added complexity and serve completely domain sharded things to HTTP1 clients and completely unsharded things to HTTP2?
Okay, so if I summarize your question, I'd read it as, how fast should we shard on HTTP 1.1? And when we get to HTTP2, should we shard or should we deliver a completely separate experience that doesn't involve sharding? Is that a fair summarization?
Yeah, basically what I'm wondering is complexity, yes or no? Mm-hmm. So added complexity, yes or no for domain sharding?
So At the moment, we don't recommend people shard to more than 2 domains on HTTP 1.1 to overcome the buffer bloat, the congestion issues. Now, and I think we can live with that with HTTP 2 at the moment. I think as HTTP 1.1 clients get less, we want to move to a world where we are not sharded at all. But as the FT's experience shows, because their largest assets, the images, are coming from Akamai, so being served over HTTP 2, even in that world where they're serving the base page from one CDN, which is using HTTP 1.1, and the images from a separate CDN, which is using HTTP 2, they are seeing performance improvements. So I think it partly depends on what content you're serving from it. If you're going to serve a large amount of content from the HTTP 2 domain, I think you're okay.
Thanks.
I have 2 questions. One is if there's more benefits to gain from HTTP 2 for mobile clients, and I was also wondering if there's any difference in support between mobile clients and desktop clients and laptops, even if the browser version is the same, so to speak.
Okay, so I'll take the browser support question first, and I'll take the second one afterwards. So support is roughly equivalent for mobile and desktop versions of browsers. So Safari on iOS 9 and Safari on OS X both support the multiplexed header compression aspects of H2. They don't support server push. Chrome on Android and Chrome on the desktop both support the multiplexed aspects, the header compression, and the server push. So the desktop and mobile browsers, their support on each platform was roughly equivalent. The question about HTTP 2 over mobile networks is one that has yet to be completely answered. There's a study out there that says Speedy was worse over mobile networks. There are studies out there that show HTTP 2 delivers its best benefits from, I think there's about 50 to 250 milliseconds of latency, and beyond that, HTTP 1.1 is faster. So there are some questions about how appropriate it is for mobile. There's also some questions about having chosen the design to use one TCP connection. What's the impact of packet loss on that connection? And we know that packet loss on mobile tends to be higher. So it does need further study. There are competing camps arguing about it. And Google created something called Quick, which is, simplest way of explaining it is HTTP 2 using UDP instead of TCP. And what they do in that is they actually use 2 connections effectively. So we may see a world where HTTP 2 goes to 2 connections to try and cope with that packet loss. But then we also have the question of, if I've got 2 connections, what's the likelihood of one suffering packet loss and another not when they're going over the same route, or are they both going to suffer the same problem? So there are still questions about its mobile deployment, I would say, or its deployment over cellular networks.
Thank you.
No one more? Okay.
Yes, a question. Is there any, using the server push in some sort of messaging system, keeping an HTTP connection alive and then push stuff when something happens?
So the question, if I summarize it, is can HTTP 2 keep the connection alive but idle? And then, so you can do the effect of what we were doing long polling in HTTP 1.1. The server can determine how long it keeps the connection open for. I've forgotten what the default for when they get closed is, but the server can choose to keep it open.
No more questions? Okay, then we take 15 minutes break.
And no more fire alarms.
Yeah, no, okay. Thank you, Andy. Okay, so now it's the last part of today, and we're going to talk about performance and culture. And we were supposed to be 3 speakers today, but Carl is sick, so we got Tobias and Mary. Tobias, me, and PA, is he here? Runs the, he's there. Runs the Stockholm Meetup Web Performance Group. So if you're really interested in web performance, you should look it up and join. And you can go to other events. Tobias works, or is the head of software engineering for Schibsted, and been working for Aftonbladet for quite a long time. So thank you, Tobias.
Yeah. This talk is going to be less technical than some of the others, and I'll try to spill out some of the knowledge that we gathered around how to build a web performance culture in a company that is not the traditional technology company. So, with some nice background music to go. So I'm now moved to the managing side, and I'm head of software engineering at Schibsted Publishing. That's part of the Schibsted Media Group. In Sweden, it's a lot of the internet companies like Blocket and Hitta and Prisjakt and almost all of the big sites in Sweden. And also big in the rest of Europe, like VG or Aftenposten in Norway, and stuff like Le Bon Coin and Secondo Mondo. And so. But this talk is mostly going to be about Aftonbladet, which, for you, those of you who are not from Sweden, is actually one of the most successful news websites in the world today. It's the primary news source of the Swedish people. It has the same daily reach in Sweden as Facebook. And if you listened to the keynote earlier today, the funny thing is that Aftonbladet and Schibsted is now part of like the front runners for the fight for the open web against the internet giants like Facebook and Google and Apple and so on. So it's it has a quite unique position in the media landscape in the world, together with there are in very few countries that the media sites have so much direct traffic as in Sweden and like in Norway and just a few others. But this talk will be about performance, web performance. And as we all know, web performance is a really important technical concern for the systems that we're building. But I would say that this line of thinking about web performance as a technical thing will not at all help you. It has to be treated as an important business concern. Because just having performance, if that doesn't mean anything to the business, then you're just spending resources on something that's kind of useless. So the only value out of your optimizations is that they actually help the business. Kind of, at least if you work for a for-profit company that has kind of exists for the sole purpose of doing business. And luckily, I happen to be in a company that I'm going to spill some internal secrets here from the Aftonbladet online product strategy for 2015. Performance, and this is like the business side of things, the product strategy. Performance is at the core of all product decisions. And this is from a company that it doesn't. It's not a technological company. The core of everything is the newsroom, earning money. And to understand how we got there, I'm going to start from the very beginning. And by that, I don't mean like in 1830 when Lars Johan Hierta stood on the streets and printing out, renaming the newspaper every time it was forbidden. But I'll start here. In the beautiful days of early web, in 1994, when Aftonbladet got onto the web. And as we learned from the other Tobias, these are GIF images because JPEGs didn't exist back then in browsers. It actually has some really good performance characteristics, this page. And you can find it, it's still available on the web. And the articles there, they work great as Facebook instant articles if you want to do that. It looks awful in iOS Safari, but in all other browsers it works fine. And then, you know, from there on, stuff happened. And everything built organically on top of that. And the next big milestone in the history of web performance was in 2006, of course, when I was high. So when all the web performance movement, or if you want to call that, started, it was like in 2007 when Steve Savvy's first book came out, and so on. We were in a situation where if you went into, I don't know which Google product that had that tagline, but we could see that Aftonbladet was slower than 98% of all websites in the world. So we kind of started from the rock bottom. And it makes sense because really big, complex news websites are kind of the worst case of web performance. You might have seen the slide earlier on the third-party requests. That's probably a news website, I would guess. Lots of images, lots of third-party content from display advertisers and all kinds of other integration that you want to pull in, social media and stuff. So when you look at it now, I would say that you could use that. You could use us as a baseline. You should be able to, in 2015, to be at least as fast as Aftonbladet. If you're slower, you really should do a better job. But we took this up as a kind of a challenge. Okay, we start from the bottom and we want to get up and try to do some incremental stuff to kind of increase the speed of the page. And the easiest way to do that was just to remove all the third-party content and optimize the stuff that you could control. That's probably how most people start off with optimizing stuff. The issue with that for a big website is that it's the third-party stuff that is kind of the problems. So the next really big milestone, or you could say the first, was in 2010, where we changed how ads are integrated into the page. We were quite early on with the whole non-blocking ads thing. And this was implemented with the friendly iframe technique during 2009, 2010, and so on. And it was done. It was motivated on the sole the sole motivation for it was to increase resilience. At that time, the ad networks were always a little shaky, and having them blocking the access to the rest of the page or to everything, showing just a big blank white screen, was deemed not acceptable. So we used that fact to change how we implemented ads. And that's kind of one of these things. If you want to do technical stuff that actually impacts the bottom line. I mean, ads were the like 95% of the incomes to Aftonbladet at that time, or whatever. It was huge, and changing how they worked on the page, and in that case. In certain areas, we were actually reducing the value of these display ads because we didn't give them the complete full access to own everything on the page. We had to find some business motivated reasoning, and it was very successful. The page load time dropped 40%. Which kind of that's a cause for cake. At least if you work in my company, you always have cake. Every week we have cake. But it's kind of useless as a measurement. We have reduced page load time 40%, but what does that really mean? Well, from the A/B tests that we run, we were able to increase the visits per week per user with 7%, and the page views per visit by 18%. And now we're getting to something that's actually important because this impacts the business. We had a business that were really based on getting as many ad impressions as possible. That's how we made money. And improving page views per visits and visits per week, it has a really good impact on like the bottom line. Unfortunately, these were the tests from the A/B testing part. And when we actually deployed this in production, we had way less improvements. And I always think of these numbers, and whenever I hear someone showing numbers of how they improve stuff, that it's probably just from the A/B testing, and you skip the rest. So what really helped us out here was that the sole motivation for doing this was to increase resilience. And the day that we deployed this was actually, when we flipped it on for everyone, was when one of the big ISPs in Sweden, I think it was Bredbandbolaget, lost every connection to everything outside of Sweden. And our ad service were in Germany. So a lot of websites went total blank at that time. So we just flipped the switch and had everything except the ads load just fine. No, that's for the onload event. This was back in 2010 when people still cared about the onload event. So that's the actual onload event. So just increasing the parallelism in downloading stuff actually made it up to that. So based on that, we could continue. we had the kind of the business motivation for doing web performance. And we did that kind of in an incremental fashion, and unfortunately that's still how we have been doing it on the desktop side, at least up till now. But in 2012, we had the chance to rebuild the mobile experience. That was kind of when mobile really took off. So we rebuilt the mobile site kind of from the ground up, with performance as the core concern. Luckily for us, this was kind of just before everyone started to care about mobile. So we had pretty free hands on that. And the result was this graph, page views per visit. For like the last year, the editorial staff had tried to optimize how they built the website and to increase the recirculation to get people to stay longer and increase the page views per visit. And then we launched in April, or might have been May. I took that little jump there, partly because we changed how we measured stuff. And then the really nice, like the textbook approach, it takes time for performance to actually pay off. Once you have learned that a website is slow, it still stays slow for a long time after that. So a gradual increase in page views per visit. And this graph has helped us a lot, because it shows, and it really got the company to understand that by doing technical stuff, we can do improvements that are leaps beyond what you can do with just the manual labor of the editorial stuff. So, performance is an important business concern. But how? How do you work with that? Missing question mark. Something that has worked really, really well for us when we set out to do something and set out to optimize. I mean, when you are to optimize something that's big and complex, you have to kind of cut it down to something that you really can understand, to identify the one most important thing, and then optimize that first. So when we did for example, when we did the mobile side, this is like from some days ago, but it's pretty close to how it looked in 2013 conceptually. We looked at the site and decided, okay, what is the one most important thing on this site? And decided that it was to get that first ad on the screen as fast as possible without blocking out the content. As you know, ads are important for the bottom line, for the picture, but we can't let the ads block the experience. And unfortunately, when it comes to display ads, kind of the whole web performance journey that we have done from 2007 and 2015 has just gone way beside them all. The core of the display ad industry is still based around sending document rights and doing serial requests to a lot of different services, a lot of different DNS lookups, a lot of services that kind of they don't have keep alive enabled even. And that's, we have to live with that. We have to accept that, and we can make ads as fast as possible. We actually did a concept in this case where we redid this first ad, because this is the ad that really has to be fast. We redid that to a new ad format that loaded as fast as it was possible with the ad service that exists. And it had really good impact. It actually had really good numbers too, but it was impossible to sell because the ad buying side of the business, they're also not there right for web performance. So we had to revert that, and we were still hoping to jack it in someday. But understanding that this is the most important part helped us tremendously in how we were to prioritize stuff. We of course didn't. We wanted that critical rendering path to be as short as possible, but we also had to kind of inline the stuff that needed just to load that one ad, and then the other ads they could wait for some other stuff to happen. So identifying that one most important thing, and if that is related to the business of your company, that helps. The other thing that is really important is that this is an area where we're on the web. Things are moving fast. So we did some really kind of groundbreaking work on that website in 2013. I did some talks. We wrote articles and also in a book. That article on Smash Magazine is kind of fun. They wanted to name it "Solving the Responsive Image Performance Problem," but we were kind of Swedish, so we could settle for addressing the responsive image performance problem. And kind of that whole solution and that article, like 50% of this is just void now, because we now have the picture element, and also some of these other stuff that we really did for this website. I mean, this was almost 3 years ago, so a lot of stuff has happened since then. So the best practices then are not necessarily the best practices now, and not being attached to your wonderful solution is really core to the performance culture. Building an interest for trying out something new, and just realizing that everything that you have ever built is probably crap. At least if it's not crap now, it will be crap in the future. So the other really important thing here for this whole performance as a business concern regards to metrics. We need to have some numbers to work on. And to have those, we don't just need numbers. We need some actionable metrics that matters. As I said, when we started back in the days, we had kind of the onload event and the page load time. That was the only kind of metric that we had, and that's why we optimized for that. And then we realized that metric was kind of, that didn't mean anything, or very, very little. So we had to find other metrics. Earlier today we mentioned stuff like the speed index, which I think is really great in theory. But when you have a above the fold that looks like this, you realize that when you want to measure when everything on this page has loaded, you see that it's mostly not controlled by us. So you get these big variations in the page, in the speed index value. So then you have two different options. You can either just, okay, we don't care about this third-party stuff. We test it without them, or we test it with some reference images. Or we just give up and look at something else. And in our case, it has been really useful to instead define our own metrics and look at using timings and custom metrics and to look at if the most important thing is how fast can we get that ad on the screen. That's the metric that we should use and that we should track. Also, once you have these numbers, you really want to make them visible. So big screens everywhere, having them in emails to important people. But you also want the less important numbers to be less visible. I actually picked that screen there because of that screen, which is taken from our internal web page test. That shows a lot of really interesting stuff, but no one actually looks at it because it just shows too many numbers in the same way. So it's really hard to know if you don't know exactly what each is, which one is the most important, what should I look at, and what should I do about it. So making the less important numbers less visible is actually just as important to get the business side of things to make these metrics actionable. And also, when you work in a company that is not purely a technical company, you really want to use metrics that make sense to normal people. And in this case, normal people are journalists, editors, working on writing articles, reporting news, doing the stuff that they really care about. And then having them starting caring about asset weights and stuff like element count on the page. That's really tough. But we found out that the combined asset weights and the number of images and the number of DOM elements on the page is really important for us. So what we did was we actually kind of found something that correlates to that, which is the page length in pixels of the editorial area without the ads. That's really understandable for someone who works on this. And can you take action on this metric? Once the alarm sounds that the page is too long, yes, I'll just remove a bunch of stuff from the bottom of it. At this point in time, the front page was kind of like fully manually managed. So to get to the real issue, which is the assets weights, the number of images, the number of DOM elements on the page, we actually had to invent this kind of weird metric of the length of the page that we measure continually and send an alarm once it passes the magic threshold. And we try to avoid discussions about why we can't add 200 pixels more to that threshold. There were actually a time when the actual page length has had a significant impact in some versions of Chrome on desktops with the Retina screens. But other than that, the number of pixels actually isn't that important. The other thing that I really think is important if you want to get this into the core of your business is to make sure that you integrate the performance metric into the analytical tools that other people use. And in this case, in our case, the other people, that is the analysts, the analytics departments that work in tools like Adobe Analytics or something. Because otherwise, it's very easy that the real user monitoring stuff that's the technical measurements. But it's when you can combine that with the other business data to find out if what's most important for the recirculation values. Is it the page load time, or is it that the user is actually interested in sports or whatever is on this page? And so on. And to get these important metrics onto the same dashboard and onto the same reports as everything else is really powerful. So I would really encourage you to try to get as much as possible into the same tools that are used for analytics, for other types of analytics. And if that's impossible, you should at least try to get them to change the tools. So basically, what web performance all comes down to is that you try to find the best option that exists today. This was actually what in kind of 2009, I think, where I had a discussion with Steve Souders when he was here. And that was his advice, and I kept it with me. At that time, it was putting ads into iframes, friendly iframes. But there are really two key elements of this. It's that we should find the best option. That doesn't mean that it's necessarily a great option. When you have to deal with third parties, stuff that's out of your control, when you have to balance different concerns, you will most likely land in compromises. But that's good. I mean, we're Swedish, right? So you should strive for finding the best option that you can do. And come back to what I said earlier, the best option that exists today. And it will probably not be in the future. Like now that HTTP2 is coming, there are a lot of stuff that we really have to just relearn. And also, to really get this going inside your company, what you need is you need to create a performance culture everywhere. But to be able to uphold that, you need to have some spearheads or some like the internal performance gurus that can drive this. And when you are optimizing, don't just take everything that is said on the presentation like this for granted. What we have found out is that a lot of the stuff, the best practices, a lot of these kind of measurements, they might not apply to your situation. If you have a website that is just the typical ordinary, very small website, you can go for whatever whatever rules are written by someone else. But if you live in a complex world, you really have to find your own way forward. So don't blindly just trust the experts on this, which includes don't trust me. And look at how you can build a culture within your company that can be really good for the web performance. If, and only if, that's also good for the business. So I think it all comes down to starting with you. I guess you're mostly technical people in here. Starting to think of how will web performance impact the business and go from there. Thank you.
Thank you, Tobias. So do we have any questions?
Hi. Tobias, you mentioned the page length here.
Yeah.
Page length, isn't that something that you can work around by lazy loading content? Like instead of making requests for all the images in the page, maybe lazy loading them, and then as you scroll down, you make requests for the content that you're not rendered yet?
Yes. The kind of interaction that we have on Aftonbladet is really very much a click at an article, read an article, go back to the page, and the back issue, at least before, had really problems with finding where you are on the page if you rely too much on lazy loading and so on stuff. So we had those kinds of issues that when we did the experimentation, then we found out that lazy loading was actually added too much trouble for it to be worth it.
Okay, so I have one question. So Tobias, how do you highlight like the most important metrics you use? Because you showed the graphs you had, but you had a lot of things, and you said you need to highlight the ones and make the not so important, not so visible. How do you actually do that?
Yeah, we have other screens too, showing some of these numbers. Currently, most of our metrics have been built on custom-made stuff that runs things on weird servers. So we made these screens with the important numbers really big. We got them put up on in the newsroom floors, and we now are working on integrating all kinds of metrics into some shared dashboards that you also, when you look at how many Aftonbladet, how much Aftonbladet Plus did we sell today, you can also find the important metrics from the web performance parts. So we're kind of redoing that as we speak.
Okay. So, perfect.
Hi. So, from basically a metrics standpoint, do you put it in the hands of the business to decide and present which key metrics you guys need, or do you try to influence the business side by kind of leaning or targeting specific metrics that are easier for you guys to work with to basically be able to do more work around performance?
Yeah, we actually have analytics persons, the web analysts within our development teams. So to really not have to do that kind of discussions, and I think that's really great. because it is so very closely related. They need us, we need them. We actually now have the web analysts driving a project to just reduce the analytics scripts on the page. The number of tracking scripts on the page. They want to get rid of everything but one or two. So that's also something that I would really recommend if you can, to inside your agile-ish teams, get analyst people there. They don't need to be full-time, but a dedicated person to the team.
Okay, thank you.
Up the stairs.
Okay, so the next speaker, I don't know if you know her. She's the geek manager, Mary, and she currently works at Marks and Spencer, but she has like a long history of different great places. So, Mary, when you're ready, please go ahead.
Awesome. There we go. Hello. Is everybody asleep? We all okay? Okay. So as I said, I'm Mary. I'm South African originally. If I start to talk far too fast, everybody just do this, and I'll try and slow down. But I do talk too quickly sometimes. And I'm from a hardware hacking background. So I, at the age of 15, built part of South Africa's first satellite, which we're a poor enough country that we had to have our satellite go in as ballast on a US satellite. So I think that basically was just like there to make up the weight to get it into space. Who's got kids? I'm not a parent yet, but my advice to you is don't let them do anything cool when they're young. I soldered something that went into space when I was 15. I basically, it's all fucking downhill from there, right? I can never be as cool as I was as a 15-year-old. So I ended up in the UK, studied computer science, ended up mostly in artificial intelligence, which is, mostly all of those people are doing big data these days. But I stumbled into Procter & Gamble and ended up there for a bunch of years. I wrote a book about project management, which is completely unrelated to performance and therefore in no way worth pimping to you guys today. And since then, I was part of the team that built GovUK, helped scale them up to the government digital service. I curate and host the lead developer conference, and 7 weeks ago started as the CTO for M&S Digital, which looks after all of our consumer-facing technology for Marks and Spencer, which is a retailer in the UK. And so I don't need to tell this room that performance matters, but I think we care about it, as Tobias has just been saying, more from a technical point of view. And I find it more interesting to think about it from the other point of view, that we like to believe that people are completely focused when they're using our sites, right? Basically, we're kidding ourselves. Most people are trying to do 17 different things at once, and so if we think that it's genuinely the core focus of their day to use our website, then we are wrong. And the two most useful stats that I've found in helping everybody care equally about performance are these two. One, that 75% of users will leave a site that takes more than 5 seconds to load. That's a very focuses the attention of your CEO of your .com company very quickly on how performance is important when they see that. And I love this one, that almost 40% of people have been have ended up cursing, shouting, or throwing their phones when something takes too long. It makes it feel a lot more real to people. And so what I'm going to talk about today is a couple of anti-patterns of things that we tend to do wrong when we're trying to make performance and making performance matter part of our day-to-day work, particularly in an agile setting, but mostly a bunch of patterns of how we can do this well. And so we all know performance is really important, but I think very often what I see is teams trying to only worry about it right at the end. They'll build their new feature, they'll try to get a new release ready, and then right at the end they're suddenly like, oh, did we check that it doesn't slow down everything by like 10 seconds? And sadly the answer is often not. I'm now a little worried that that has stopped because he usually keeps going. There we go. And so I feel so strongly that about this being an anti-pattern, that we shouldn't leave these things right to the end and only worry about them after the fact, that I have like a double nope GIF for you, right? I have the badger, oh, and again. See, when I tested ahead of time that my GIFs would all work, and then I'm screwing it up now, which is kind of sad. So Note Badger and Note Llama would like you not to leave it right to the end, please. And so again, rather than worrying about it afterwards or not worrying about it at all, which a lot of teams seem to do, let's talk about how we bake it into our process. And this one feels a little bit kumbaya, but the first thing is to write down your team values, get everybody together and say, what do we care about? And there's some good examples of this, like refactor as you go. The Boy Scout rule is one that a lot of teams will pick, of leave everything better than you found it. Do your refactoring as part of new feature development rather than letting tech debt accumulate. Another one that's quite popular in a lot of my teams is the no seagulls rule. Is everybody familiar with the seagull style of management? Fly in, shout at everybody, shit on everything, fly away again. It's clearly not as popular here as in Holland. That gets like, it takes a minute for everybody to calm down after I say that. But the other thing that a lot of teams get to is, well, do they care about from a technical honor and craftsmanship point of view? They do care about things being fast, and getting that to be something that your individual teams articulate as something they care about is really helpful. And the other thing that I'm hard pressed to find a team that shouldn't care about this is making user experience something that you say, this matters to us and we will do what we need to make sure that it's there. And so make caring about the user experience part of your values. There was a great question in this room earlier today to Barbara about how do you get the designers to care. You want designers to care about performance. You have them sit in on 2 sessions of user research on a phone with 3G. They will care so much about performance, you will not get them to shut up about it ever again. Because watching any end user try to access any website on 3G makes you care an awful lot very quickly about performance of websites. So please make caring about the user something that your teams talk about and that you talk about, and that helps you make performance something that's intrinsic in how you build things. The next thing that's a pretty useful pattern is to arrange work as deliberate practice. And this term of deliberate practice is becoming more accepted. Who's read Outliers? 1, 2, okay. It's a little bit pop-sci and a little skimmy over the details. Talent is Overrated is a better review of the psychology literature and things like that. I'll post these slides and links to all the books afterwards in case anybody's worried about forgetting the titles. But what's really interesting in all of this field of study is that people went looking for something that they genuinely believed existed, which was talent. And a lot of the research started in places where everybody really believes that talent is a factor, like music. So they went to the best violin school in the world and said, who are your future world-class soloists in orchestras? Who's going to play in a world-class orchestra, but they might not be a soloist? And who are your music teachers of the future? And looked at what the difference between them was. And this is where the 10,000 hour rule stuff comes from, of there just being an inordinate number. And what gets glossed over a lot when you see the kind of Harvard Business Review or a little bit too popular science kind of articles is the type of practice it was. It's not just spend a lot of time doing a thing, it's spend a lot of time doing the thing you will learn the most from. So with violin players, it's individual practice, which every violin player I know tells me is the worst part of playing the violin. The playing with the orchestra is much more interesting, much more engaging. But the thing that's most likely to predict how good you're going to be is how much time you spend practicing on your own. There's another great example which is about the different sports and where having access from an early age matters. And the kind of canonical story is a guy was watching ice hockey. I assume he was Canadian. I love that Canada's like this massively progressive, liberal country. They've just put a parliament in place that has the best representation of any like set of politicians you've ever seen in the world. But their major like sport is just about beating the shit out of people. It's brilliant. It's wonderful. Ice hockey, in fairness, though, isn't quite as violent as water polo, which is the sport I grew up playing and why I ended up as a bouncer in my later years. But this guy was watching hockey match. His wife was clearly not enjoying it quite as much. She was reading the program and said, "It's really weird that they're all born at the same time." And he was like, "It's not true. This one's 24 and this one's like 19. And wow, look at how hard he just hit that guy." But then she said, "No, that's not what I mean. They're all born in January or February." And this piqued his interest and he went and did a bunch of research into it and found that in fact, it was really true that almost all of the pro ice hockey players who had grown up in North America were born in January and February. And through a bunch of research, eventually worked out that this is because in Canada, you start your childhood sport of beating the crap out of somebody else at the tender age of 4. And when you're 4 and you're born in January or February, you're the oldest in your school year. And the difference between a 4-year-old and a 5-year-old in like coordination and heft is quite significant. And so you're a lot better at ice hockey if you start and you are 4 years and 11 months old than if you are 4 years and 0 months old. But what's interesting is that that snowballs over time. So because you're good when you're really little, you get to play more often, you get to play weekends, you get selected for the first team, you're doing practice in the morning before school, you get a lot more opportunity to get better, and you get a lot more opportunity to perform. And the counterexample that's really interesting is basketball, because ice hockey, you need a lot of things. You need ice, you need presumably a lot of armor. You need the puck and the stick, whatever that is called. Like, you can tell I came from Africa, right? I have no idea what all of these ice-related sports are about. And you also need a whole bunch of other people to beat the crap out of, evidently. And that's not very easy to kind of rustle up in your backyard. Whereas basketball, you can pretty much improve your skills in basketball as long as you have a ball. And if you have a hoop, then you're doing even better than expected, right? And so you can get deliberate practice in some activities without needing a team, in some sports without needing that more detailed or kind of structured setup. And so the core thing to know, though, is that we're good at what we practice, providing we can learn from it, and that the definition of practice is quite specific. And so you need to want to do it and want to exert the effort to improve your performance. You should take into account your existing knowledge. You should get immediate informative feedback and repeatedly perform the same or similar tasks. And that's what I think is really interesting is when you ask people whether their day-to-day work as a professional is designed for them to learn from it in this way, I've never found anybody who's like, yes, I have that nailed. That's exactly what I do every day. If you are that person, I want to talk to you, I want to interview you, because I would love a great example of this. But we're very good when we're kids and when we're at school at designing experiences that we learn a lot from and that we get a lot out of. We seem to be a lot worse as adults of actually designing our environment and our work that we learn the most possible from it. And so there's 3 different models of deliberate practice. The sports model, where you go, how can you get a lot better at rugby? You lift a lot of weights, you do a lot of sprinting, you eat a lot of meat, and to do with teams is to help them when they're spiking a new feature or trying to decide what the best approach for a new kind of need is. Do it on a 4-year-old phone with a 3G connection. People very quickly start to realize that maybe the bright and shiny thing that they were planning is going to be not brilliant from a user experience point of view. Or better yet, look into your own stats and see what the device connection browser combo is with the highest bounce rate. So who's coming and getting so frustrated with your site that they're leaving almost immediately. See if you can get your bounce rate by your kind of combination of devices and connections, and see who's having the worst experience right now, and try testing from their point of view as part of development, as part of when you're writing a new feature. But I think the thing that helps the best in terms of this deliberate practice approach and also the immediate feedback loop is to get your testing, tooling, and instrumentation in place. And we talk about automating all the things. I love this quote that the future is here. It's just not evenly distributed. These are things we know how to do. We have all these tools. We have all these approaches. But I find so few teams that have it as part of their continuous integration, as part of their build process, as part of their route to production for new features on their website or in their app. And I think that's the thing that we could actually most usefully do to really improve performance across the web, would probably be to build these things in and to more evenly distribute the things that we already know. It's not rocket surgery, as one of my friends likes to say. And so if you take the approach of saying, how do we make sure this team knows that they are making things better and not worse? We have web page test, we have sites Speed.io, we have Grafana, we have, there's a whole bunch of companies very willing to take your money to give you a software as a service approach to help with this as well. But I find so few teams that actually have it integrated into their tooling and ways of working in instrumentation. There are a great many people who go, I think this is a great new feature. It's gonna be brilliant for our users, and they don't know until it's live a month later that it's slowed everything down by 3 seconds. Because, like somebody said earlier, they're testing on a high-performance machine, on a high-performing network connection in the latest browser, and it's their job, so they're not trying to keep in control of the hoovering cat while it happens. So the other thing to do is to define done appropriately and make sure that we're not that we know that making sure that it's going to perform well is part of it being finished. When you do that, it's really easy to walk out of a conference like this one or like Velocity and go back and just be like, everybody is shit. They're all just doing it wrong. So the other thing to remember is that all humans, in fact, all primates, I think this is fairly universal, go through a process. They go through a series of stages when they're learning to do anything well. And it's a lot like learning to drive. So initially, you're unconsciously incompetent. You're doing it wrong, and you don't even know it. You move on to being consciously incompetent. Learner drivers are still crap at driving, but at least now they know what they're doing wrong. They're wincing every time they grind the gears, or slide the car, or whatever. And then they eventually get to being consciously competent. So somebody who's just passed their driver's license, they will never again exert so much attention and effort in driving well as they do immediately after passing their test. And you get to the point, though, where you're unconsciously competent. I can't remember the last time I actually remember my commute, because I am just able to drive without thinking about it. I'm mostly able to, I haven't had a crash, so I'm really not killing anybody, but it's not taking a lot of my active attention. So the other thing that's interesting about this, and Kathy Sierra has written about a great deal that's very interesting, is the people who are already unconsciously getting it right, they're automatically doing the right thing, they might be the worst people to teach in your team. So if you've got somebody who is, every time they build a new feature, it automatically seems to be high performing, accessible, progressively enhanced, like all of the things that we would like things to be on the web. sometimes they're not even able to articulate how they're getting it right for somebody more junior who needs to learn from them. And sometimes finding the person who can better coach is about finding someone who's still got to concentrate to do it well, and they can teach the people who are a little bit further behind a lot better. One final anti-pattern, though, is this tendency to say, it's going to cost you extra. I have a massive, massive bugbear about this, to the point it makes me deploy the best cat gif in the history of the internet, which is fuck this thing in particular. We should not be saying that making something fast is an optional extra. We should not be having this, the kind of conversation you have with your mechanic, where you go, how much will it be to make it roadworthy? And they go, it's going to cost you. But we do. We have those conversations, and I see so many agencies and so many in-house teams having conversations like making something accessible is an extra, having some kind of quality strategy is an extra, having things that are fast shouldn't be an extra. It isn't that it doesn't take work, but our professional pride should make us plan that into the process rather than make it extra. So I'll not get too heated about that, because I appreciate I'm in Sweden and I'm clearly a little hot-blooded for here, not least with the swearing. And then the final pattern is to measure reality. As I mentioned earlier, I've just joined Marks and Spencer as to lead their tech team, and I've actually been really pleasantly surprised in this particular area. So there's a guy called Andy Nielsen, who's just done a talk a couple of weeks ago at Velocity, who's been leading our PerfOps team. And so they've not only been doing some great work in this area, but he's been doing some amazing work on instrumenting our actual live in reality user experience. So we've got plenty of testing that shows us what a synthetic, like a proposed or a imagined user would experience. But he's also got us to the point where we've got instrumentation that shows us what's actually happening for our real users both on the sites, on the apps, all the different ways that our customers interact with us. And I thought today I'm mostly going to say that talk is brilliant. The slides are up. I think the video is about to be up shortly, so I'd recommend going and watching it. Andy did a really good job. But I thought I would share just a couple of the examples that he includes that I thought were really fascinating as I joined M&S and had a look at them. So one of the insights that we found was that actually our tablet performance is the worst right now. We are a little bit reliant on Angular. It doesn't work brilliantly on Apple tablets in particular. And so if this is how fast have you got the experience? We want as quick a bulge as possible. And actually, this one, the green one, is not brilliant. But what we see in the UK is in the evenings, tablet's pretty much our most popular device by far. Particularly, the demographic behavior seems to be that anybody over 50, they're shopping on a tablet from 7 o'clock onwards. And so this helps us to realize that one of our areas we most needed to focus on was making tablet better. And in a world where people are just kind of adjusting to the idea that non-desktop is a thing, this was really, really useful to do. I love this one. We thought we had an issue because we saw a sudden drop-off in traffic until we realized that it was the solar eclipse, and so everybody had put their devices down and gone outside. Which is kind of awesome, right? We actually went outside and looked at the sun disappearing, but it's been really interesting to see that starting to happen. The other thing that's interesting in this as well actually is even in the middle of the night where there's not a lot of traffic, we've got a lot of strange slowing down happening, and so we went and had a look into that as well. And then this one was great. So we saw a massive drop-off in traffic and a massive increase in the length of journey or the length of loading for people, and we had a third-party tag issue. We had some marketing tags that were slowing everything right down. Somebody had let something go into production in a way that it was really, really slowing things. I think my recollection is that we'd accidentally turned off async for a load of third-party things that were loading, and so it was blocking the render. But this kind of monitoring helped us find it and figure out what was up, and then fix it very swiftly. But the other thing that I would include is we have proven beyond a shadow of a doubt that making things faster makes more money. We were able to see that every half a second that we reduce improve the speed, we see both customer satisfaction go up, we see abandoned baskets go down, and we see completed transactions go up. And so it's also brilliant for me coming in new into an organization to not have to start this fight, not have to begin this conversation, because we've already got the instrumentation that shows us that whenever we invest in performance, whenever we make things faster, it pretty much immediately converts into actual pounds and actual improvement in sales and customer satisfaction and engagement. And so, to summarize, bake these good practices in. Don't just think about what's the technical thing that needs to be done. Think about how you make it part of how people work every day, day by day. It is generally better to help a team decide what they care about than to tell them what they care about. I wouldn't recommend that. Encourage folks to value the user experience, including performance. But as I said earlier, if you want to convert anybody to caring, just have them watch some user research that's happening on a slow connection or a 2-year-old device. Very, very, very quickly they will be converted. Arrange your workers' deliberate practice and figure out whether people need to get better at chunks, automatically doing the right thing, whether it's like sports where they could go and develop some skills that would then be useful in a different context, or more like that chess model of this isn't rocket surgery. We could just see what the right thing to do is and adopt it. We could find a grandmaster. You've been listening to some of them today. Various people I'm going to try and bribe to come and do talks for my team as well. Do performance testing katas, help people, especially junior folks, to know how to test this as part of the development that they're doing. Help your designers know how to think about performance, and you'll immediately see the team come together in a better way. Integrate your perf testing into CI, CD, instrumentation, tooling, and define done appropriately, but remember that nobody does this perfectly every time straight off the bat. People need time to develop those skills and go from unconsciously incompetent to unconsciously competent. Nobody gets there automatically. And then measure the synthetic and the actual user experience of performance, because it's great to have the tools that we have, but it's even better when you can measure what end users are really experiencing and see the connection to the commercials as part of that. Very similar to what Tobias was saying a minute ago. And finally, just be awesome, but remember that performance matters. We can all be so much better at this. We just have to make it part of how we work rather than an additional extra or a mechanic type conversation. Thank you very much.
Okay, so do we have any questions?
No question, just an escape. Yeah. It was so bad, he must leave immediately.
No. Thank you.
Cool.
Okay, so I have one question. Yeah, of course. So, what do you think? How long time? I mean, so getting people into the culture and getting everything done. So, I mean, where should I actually start? Say I'm coming to a company and
So my approach tends to be one team at a time. And I think getting one team to have the right tooling so that they know when they're making things better or worse is the thing that tends to start moving things around. One product owner really caring about performance and making sure that the stories that relate to that are automatically high up in the backlog is really useful. And as soon as you've got one team that are showing that their business KPIs are improving because they've improved the speed of, whether it's their part of the site or their app or whatever that team looks after, and then them sharing. It's very much about it being unevenly distributed. You'll find in any big organization, you'll find a team that has somebody who really cares about this stuff, who keeps up to date, who reads all of the literature, and they're 10 years ahead of all the other teams, and finding that, amplifying that, and helping people have the tools tends to be the thing that makes a big difference. And then the best thing is when you get to a point where teams are asking for help getting better at this, where they're coming and going, that team over there's got it integrated into their build process, so they know, could we have it integrated into ours? The minute somebody's in that mode, it's their idea. They want to make it happen and they're keen to get help. You get adoption a hell of a lot faster than if you go out and try and kind of order everybody to do better, or what I've seen sometimes, and it goes a little bit wrong, is people to set measures where then people will do anything to hit the measure, and you've got to be really careful about that. You end up with a lot of what I call watermelon metrics, where they're green on the outside and bright red on the inside, where the number that you've told people matters has been made perfect, but all the actual user experience is fucking terrible because people have just gone for the number, not for the actual experience that needs to be better. You always have a question. It's fine.
Would you recommend having like a evangelist team inside a company that spearheads this development, or would you recommend placing the head of performance on one person inside each team?
So what we have done is to have Andy, and he has a small team of folks who can help guide all the other teams, and then we expect each team to care. So we enable them by having a small team in the center that just like solves the problem once, rather than 20 teams going off and trying to solve the same problem. For something like having performance budget measurement in the build process, it's better for there to be good guidance on that rather than everybody trying to start from scratch on it. But I'd echo what was said earlier, that having good analysts can be really, really helpful. And what we find is a lot of our product owners are quite into their analysis, so they're looking at the numbers and they're judging it from that, and they just need sufficient guidance. I think if it were a much smaller organization, I'd probably have the other approach of have somebody in each team, because we wouldn't then have the capacity to support having a kind of small expert team that helps all the other teams. Anybody else?
Okay,
Cool.
so thank you, Mary.
Thanks very much.
Okay, so this is the end. So thank you, and I hope you had a really good time today. And look up meetup.com and the Stockholm Web Performance Group. And if you're interested, you can join that and come to other meetings. Thank you.